Hey there, it's Firefly with another game development livestream. Today we will be looking at material mapping, which is the process of adding roughness and metallic information to all of our materials. And we're not going to do that per vertex, but we're also going to do that per texture pixel. So we're going to draw some new textures with material properties, and we're going to apply those to all of the materials and all of the things that we render in the game world. So let me open up the project here. And there's a few things that I want to show you before we start on this new material mapping process. This week I did a few things in the engine to fix bugs that we encountered during the last live stream. So let me show you the results of that. I've been working diligently on some of the parts that were less than optimal last week on the last live stream. So let's open up the game. I turned down the volume a little bit more so you don't really, so it doesn't really get in the way of my voice. So I've been building some things locally, as you can see, just placing various block combinations. And I've made sure that the vertex normals and all of the texture normals are now perfect. And in order for all of the stairs blocks, so these upside down slopes are now great. The regular stairs are now great. I also fixed, as you can see, the tapered stones. So our roofing tile texture finally works. It's actually looking good, and as you can see, it's reflecting. So one of the things that material mapping will help out with is that this reflection in between of the roofing tiles, so kind of the background of this texture, it's also very reflective at the moment. And with our material mapping applied, the thing we will be doing today, so we're going to have to update this texture as well, we can kind of like tone down the roughness, or like increase the roughness of the spots in between the roofing tiles, kind of like making it an anonymous background material if you want. And we're going to do that for our existing textures. So we've got the wooden planks, the roofing tiles. I made a new wooden plank tile or a texture for the column blocks. So that's this texture, as you can see. They look fine, and online with our computer machine. It also gets applied to these chair blocks. They don't look like chairs, but this is the way stacked chairs render in the game. So it has these very thin poles. So that's going to be good. I fixed the missing bottom side of these lanterns, so that was kind of an artifact of the way that these are now rendered in the new engine compared to the old engine. So that's fixed. We have our table blocks, which look good. There was also a bug with the table blocks where the bottom side, never mind this table, let's build a wooden table here. The bottom side of the tables actually didn't get a normal map applied, and it also didn't get ambient occlusion applied. So the bottom side of tables, last time we streamed, looked less than optimal. I think nobody picked up on it. Even I didn't pick up on it because it's a very subtle effect. It's a very subtle bug that was there. But while working on on fixing the normal maps for this, I found out that it was actually only using the albedo channel. So that's the color channel for the material, and it didn't apply to any advanced shading effects. And that's why some of the wonders, some of the builds that are in the game looked a bit weird in retrospect. But I only figured this out this week, and it's also fixed, so that's cool. Let's take a look at a tree bark texture that I made. So this is like generic tree bark. It's got these cuts, these grooves in it. And like fresh wood that's below the surface is always a bit lighter than the top part. I think it looks pretty good. It's a cartoony style, of course, and you'd have to see this in a full build. It looks really great in some of the builds that are in the game. So we have this build called San Rafar, which is kind of like a huge miniature world. Bear with me. Where you live as a sort of like leprechaun in a giant world where things are bigger than usual. So you live in these tree stumps, and they are made out of this bark material, and they look absolutely perfect. Do observe the way that the light reflects on different parts of the texture, and kind of like the directionality that we have in the lighting here. So that's cool. But let's take a look at the roofs here on the walkway, because those are absolutely amazing now. Check it out. Here you can definitely see that the roofing tiles have been fixed. So you can see that the top part of the roofing tiles reflects the top of the skybox, or the skybox and the sun. And they just look absolutely amazing this way. The sun is over there, so maybe we'll have to walk over to those roofs on the right side there. You can already see the specular reflection coming off of the roof on the right. So that one over there. Maybe we can take a closer look. But this was looking a bit weird last week because these normal maps, they got flipped and they got wrapped and they got warped. It wasn't as good as what it could be. And once I finally got this working, I was like, oh yeah, check it out, it looks really good. So here you can kind of see the sun starting to reflect in the top part of the roof. Hey Gaston, welcome. So Gaston, you were here probably for the last live stream when the roofing tiles weren't looking this good. But as you can see, I fixed the texture wrapping for the normal maps and everything is looking good now. So I did this for a lot of blocks already. It's just the engine needs to learn a few new tricks to get these normals applied correctly. But it's working and it's looking really great. So check out the roof on that small little photon machine demo thing over here. Also, of course, the cinder blocks below that are shaded correctly now, because these are tapered blocks too. So everything is looking good. There's a few more block types that I still need to improve. For instance, the panel blocks, so the doors that we have in the game, they still need to have a bit of tweaking applied. Flag blocks is something that I still need to look into. And there's one more type, I think the functional blocks, so the hollow scrolls and like the conveyors and the trampolines. But it's going to be good, it's going to be good. And like I said, I drew a new texture for the wooden column, the wooden pole. And we're going to improve this one today. We're also going to improve these wooden planks because we're going to add shiny metallic nails to these. That's what our material mapping is going to add. So if you take a look at this texture, you can see that we do have the nail holes. So we do have the holes where the nail should be going. It's these diamond shaped holes. But today we're going to try and add nails to this, with a metallic shading applied to it. So if we take a metal, for instance the regular steel like this, and we place it over here, you can see it looks more metallic. The reflection of this lamp in there is very shiny, very metallic-ish. And we're going to add this steel material or something similar to act as the material for the nails. It's going to be a subtle detail, but hopefully it will make it way more convincing, or like make it look really good. And those nails will of course be applied to every wooden plank pole thing that you see. So also on these stairs, for instance, we will see shiny nails here as well. Hopefully it's going to look good. So we're going to have to redraw some textures, or at least expand them, and support this in the engine. I think we can do it. I want to stream for about 3 or 4 hours today, so up until lunch. I don't really want to do a marathon stream like the ones we did before this, so those were 7.5 hours. I want to stream a bit shorter today, and hopefully we'll be able to make it work. I think we'll be able to make it work. Otherwise I wouldn't have cut the time in half. Alright, so let me draw a diagram. I'm a fan of diagrams, or at least explaining what we're going to do. I also learned that we don't have to throw this away. So let's make a diagram of textures we have and material channels that we have. Hey Infamous, welcome! So our current textures, so let's call this textures. Again, today we're going to be looking at material mapping, which is the process of describing material properties in texture maps. We already have a, let's call it an albedo texture. So albedo is the color of material, sort of. We can abbreviate this to color. And the albedo texture has got a red, green, blue channel, which is actually the material color. So this is your plain Jane regular texture style, sort of the albedo. And we have an alpha channel, which is, let's call it A, and this is the alpha of the material. Alpha stands for transparency. So we didn't draw any transparent materials just yet. I actually did, I actually did. So let me open up the engine real quickly. I drew one with alpha channel, so let me explain and let me show you.
Let's go.
I drew these rocks, check it out. So these rocks now also have ambient occlusion, normal mapping, and all of the like material properties applied to them. So they look absolutely stunning. It's a small detail, you'd think, but it's absolutely amazing. So let's go to a random location in the world so I can show you in time-lapse mode. But the lighting on this is now physically correct. So you will be able to deduce the sun location from the rocks that you see in the world. It's a small detail, but this is going to work wonders for every single block decoration that we add. These rocks are block decorations, so they decorate the top side. Hey everyone! Decorate the top side of a block. So let's enable the time lapse, and as you can see the shading on these rocks, let's take this one for example. You will be able to see the light and the sun move from left to right here. So now the left side is lit, the sun is moving to the back. Now they are backlit, sort of, so they are in the shadow. You will see the ambient occlusion come in. And now the sun is on the right side, and you will see the sun kind of like highlight the right top part. It's halfway in the shadow, so let's see if we can find a rock that's not in the shadow. Here's another one. So now the sun is right in front of us, so we see the shadow part of the rock, and now it will be on the right side, and you will see the right side of the rock. There's also a tree over here, so okay, it works, but it's, yo, hello Ibn Bari, how are you doing? It works, but we have to find the perfect location, otherwise you won't be able to see it that well. Okay, here's another rock, check it out. Okay, well, in between the shadows moving around, you actually see that like the light actually physically is perfect. Oh, there's a nice rock. This one over here. Dun dun dun. There you go. See this? Now the sun is on the left side of it. Now it's kind of like to the back of it. And very soon it will be on the right side, and you can already see the right side being lit. Check out. So even though it's just a two-dimensional element, because we're still in this sort of cartoon style of rendering, and we have these cartoon style textures, even though all of these things are cartoony, the lighting is now actually physically correct. And it's just a small tweak compared to the original artwork. I just defined the normals for these rocks, for all of the surfaces on the rock, and it just instantly works. But anyway, we were talking about the alpha channel. So alpha means that a texture is transparent. So as you can see, this grass, this is supposedly grass, this rectangle over here. This grass now looks like a square. Maybe we can find one that's in the sunlight. So these are all squares, and that's because there is no alpha channel defined for this grass at the moment. So they render as a square. Once we add alpha, so transparency to the shape, you will actually be able to make it into a grass shape. And that's what I already did for these rocks. So as you can see, the rock shape itself is fully opaque, so it's not transparent. And then all of the background, sort of where the rock isn't, it sounds a bit weird, but where the rock isn't, that's where the alpha channel is 0. So that's transparency on the rocks. Transparency on the rocks. Oh yeah. I can show you the artwork file for this real quickly. So this is a block decoration, the rock, and let's open up the albedo texture for this. And here you will be able to see that the rock is transparent. Okay, you can't see it because the background is also white, so let's draw a background on this, and let's make the background a little bit grayish like this. There you go. Maybe I should move this to the back layer. Hey, it's all live, we're doing this. Here we go. So this is the alpha channel of the rocks. So as you can see, where the rock is white, that's where the alpha channel is at its max. That means it's opaque. And where it's gray, that means that the alpha channel is 0. So that's where the rock shape blends into the background, or whatever is in the back. And let me quickly show you the normal map that I made for this. So here we go. I actually made a correct version of this sampling, or this example, this reference image. So that's working now. I have it figured out, and we have all of the individual colors, as you can see. And I just defined all of the surfaces of the rock to have a normal direction associated with it. So this shape, this face of the rock is actually pointing towards the right, as you can see. Slightly to the right, slightly to the top over here. And this way we define the way that the light should reflect off of the rock. I also made displacement map, so this is the height of where the rock is at its like closest to the camera and to the back of the camera, and from that we deduce the ambient occlusion. So that looks like this. This is where light is most likely to hit the rock when it's in the shade. So check it out. So it's all smoke and mirrors, but the results are really great. Anyway, back to our diagram. So that's what we already have. We have an albedo texture. It's called an albedo map. Textures. So we have an albedo map, which is kind of like the color of the material. So we already write that down here. Alpha of the material. So this is sort of the shape of what we have. Then we have a normal map. We already saw this, and we have RGB channels, which is kind of the XYZ vector of the surface normal. The surface normal is a technical term for the direction that light bounces off of this. So it's what we saw with the rocks. We define the right side, the right face of that rock to point to the right and slightly upwards. So you can post this on an image board. There you go, check out these doubles. So we have normal map with the alpha channel. So all of these textures, they are RGB A textures. So that's 4 color channels, 8-bit, let's call it 8-bit. RGBA. That's kind of like the textures we're working with this in this engine. The old engine uses 5-bit textures, which are more efficient for rendering, so that's why the game runs really well on older devices even. And if you don't have a like giant GPU or giant crypto mining graphics card in there. But for this engine, we're going to update and facelift everything. So let's go with 8-bit textures. So the normal map has got RGB channels, and that's the XYZ of the surface normal. Maybe let's write it down like this. The alpha channel of the normal map is currently unused. So we kind of waste 8 bits per pixel in those texture maps at the moment. And the engine supports, but we currently don't use the material. We do use the material map, sorry. The material map has got an R channel. The red channel is used as the ambient occlusion. Ambient occlusion, we can add light to this. I'm not a fan of parentheses, so let's keep it clean. Ambient light occlusion, like this. And then the GBA, Game Boy Advance channels, they are currently unused. Does this sound good? This sounds good. This is what the current shape of the engine looks like. And I'm not going to make the same mistake as before. So let's call these texture map channels. And I'm going to save this document on my desktop here, so we can open this up later in the stream. Now what we want to do is add material mapping to this. So what do we want for material mapping? What kind of channels do we want to add? We want to have a roughness map, which defines how rough the material is at certain points, so that we can have varying roughness in the texture. We want to add a metallic map, which sets up the metallic property of a pixel in the texture map of the material. The metallic map is probably going to be empty for most of the textures, because most of the textures that we have in the game are either non-metallic or they are metallic, and we just set a vertex property for this. So we're going to have to look like, is a metallic map useful? It's going to be useful for the wooden planks, but maybe we can disable it for a lot of materials, and that would like speed up the shader and the shading a little bit. We also want to add, and this is going to be a bit of a trick, we want to have an albedo mix map in here. Bear with me. What's albedo mix, you might ask? Good question. The current albedo map that we have with the RGB material color, we use this to multiply. We use this to multiply the vertex color with the albedo map. So if we have a texture map, it gets multiplied with the material color from the engine. The engine defines all of the material colors, sort of. So let's open up the code generation here so I can show you. If we have wood, for instance, as a material, which is an artificial material, so let's look up wooden planks, I think it is called. Shelves, wooden. I wouldn't go in there without you. Wooden planks. There we go, wooden planks. So the wooden planks material is an artificial material, and it has this wooden planks PBR texture applied to it, which is what we've drawn last stream. But it says color information is the material color information library wood. So let's open that file, material color information. This is sort of a common library for shading values for all of the materials, so that multiple textures or multiple varieties of textures can use the same material definition. And here we have wood, we have painted wood, but this is like the OG wood, the original wood. And as you can see, it's a orange color. It's not full brightness. We're going to get to this in a few seconds. It defines, okay, this is pretty hard to see, but it defines a saturation range and a value range. So it's 65, 65 here, value and saturation. It is not metallic, so it's got a metallic factor none, which is defined in this file, the material shading values. So we have different metallic factors for different materials. So metal is 1.0 metal, that's entirely metal, which is very logical. Corroded steel is only half metallic, because half of it is rusted, is kind of the impression that we want to give off, and half of it is metallic. Then we also have like non-metallic materials, they have 0.0 metallicness. We've got pearl and we've got sand. So sand, even in real life, has got a little bit of metal strewn in there, which is why you can make silicium out of it, I think, and glass. I'm not entirely sure on the chemistry here, but hey, it's all good. It's all good. So anyway, we say that the wooden planks, they have this wood material applied to them, and wood has got a color inherently associated with it. So that's orange 6565. So let's open up Illustrator here and look at what that color appears like. We're going to draw a box. And now I've been using these values for like the past years while working on the game. So I know that orange is a hue of 30 degrees, and then we use 6565. There we go. This is the base albedo color of wood. And then the wood texture gets mixed in with that. So if you open up the wooden planks, let's see, blocks, wooden planks, variations, and then the albedo, this. So what the engine does, it multiplies this albedo map with the color that it knows to be wood, and then you get a result. And we can actually simulate this result by placing the texture in this file. It's pretty much entirely similar to what the engine does. We're going to take the texture, overlay it on the material color like this. And then we're going to set the transparency to multiplying. And there you go. This is the base material color, or the base color for wood, for the wooden planks texture in the engine. So as you can see, it's a simple matter of multiplying the albedo map with the material texture color we already know, the material color. But what we want to do with albedo mix is actually implement this, so that we can have the texture, because we want the nils to be gray, we want the texture to have its normal colors. So with albedo mixing, we can say like, do we want it to be multiplied by the material color, or do we want it to override the material color? It's going to be glorious. It's going to work wonders. So let's close all of these windows. So in our material map, we want to have roughness, we want to have metallicness, and we want to have a albedo mix. And there's one more that we want to have, which is called a pre-lit map. We might not be looking at the pre-lit today, or we might. It kind of depends on the path we choose to go. So you can, like, this is the interactive part, let me know what you want to see. We can either go with a non-pre-lit map today, or we can go with the pre-lit and go all the way. If we're going non-pre-lit, the pre-lit stands for the light emission of a material, sort of. So a lantern in the game would be pre-lit in the sense that it has some light associated with itself. There are a few items in the game that have this pre-lit factor, or this full brightness effect to them. So there are some magical swords, there are some magical crossbows with magical arrows, there's magical stuff in the world, and all of these items and things kind of radiate light in and out of themselves, and that's this pre-lit thing. So it tells the engine how much light is already how much light is already available in this item or in this object or in the surface. We don't have a shading effect for this just yet in the new engine. We could be writing one today, and then we could add a pre-lit factor to the texture map, to the material map, because then we can make a lantern where the frame of the lantern doesn't give off light, but the center of the lantern does give off light. So if you take a look at the lantern map, people familiar with the game will know what this looks like. Let's open up the block, lantern block. It's under the L, there we go. And let's open up the large lantern block. So our lanterns are not entirely glass with just a light in there. They have this metal frame around them. As you can see, it's a very, very intricate design, beautifully designed in a way. Not only in a way, beautifully designed, period. And we want a pre-lit effect, so light being present. We might only want to add it to this center portion where the lamp or the light source actually is. We might even opt for making the corners darker. And of course, the metallic rim, the metallic frame around the lantern, isn't going to be pre-lit because it doesn't radiate light. So maybe we can create a very nice shading effect by just making the center of this pre-lit, saying like, okay, there's light radiating from this part, and then having just everything around it not be pre-lit. It might add some very intricate shading effect to it. And that holds for all of the lantern blocks that we have. So this is a column block lantern. As you can see, we could use the same trick here. So just making this center portion pre-lit so that that looks like an actual light source. And maybe we can fade it out towards the corners. We can do some kind of trickery with this. Maybe we go with the prelit path today, and we make a new texture for the lantern. So that might be the best plan. Alright, so we have 4 new properties that we have to divide over. Dun dun dun! We couldn't be more in luck. We have 5 or 4 unused texture channels. So we have 4 properties: roughness, metallic, albedo, mix, and prelit, that we want to assign to 1, 2, 3, 4 unused channels. Sounds great. Now, one thing that we have to keep in mind is for the normal map, it's going to be pretty hard to add an alpha channel to this because we actually hand draw the normal map. So we want this channel to be unused, sort of, and if it's used or if it's unused, we want it to be 255. And we want it to be 255 because we already have there's no transparency in the normal map. It is a little bit of a technical story, but hey, it's game development and we can't really avoid technical things here. So a normal map looks like this. It has a RGB component for the directional surface vector, and it usually doesn't have an alpha component to it because there's no, every part of this texture has to have a normal associated with it. But here's the thing, we can abuse this because if we don't use alpha, if it's 255, if it's fully opaque, it's good. So we want this to be 255 where possible because we're only going to use, or we only want to use this in specific circumstances. The material map is going to be a little bit easier because we are going to have to combine multiple textures here already. So this is going to be sort of a composite file. I think we can use Illustrator for this. We can just assign different color channels to different parts of the texture. So I think we want to have, let's see, roughness. We're going to use this quite a lot because we want, as we already see, almost every texture we already have is going to use this roughness map. So we definitely want that to be in one of the more often used channels. So RGB are the simplest to influence. So let's say this is going to be roughness. Then we have a B channel and an alpha channel like this. We're going to use everything. So now how do we have roughness assigned to the green channel of the material map. Then for consistency's sake, let's use metallic on the B channel here, on the blue channel of the material map. Then we have albedo mix. How often are we going to use albedo mix? So mixing different colors. We're going to use it quite a lot. So we're going to use it quite a lot, which means that we actually don't want it to be on an alpha channel. But we also have the prelit map. This is very sparse, very rare that we actually use a prelit map. So we could move prelit to here, prelit. I think that's good. So then we kind of end up that we have to assign the albedo mix to the alpha here. So albedo mix. This would assign all of the color channels. So we have 4 new properties. We assign them to different material, texture channels, color channels. Does this make sense? So the albedo map is pretty perfect. We can't really do anything about this. This is just the way that it is. We could do some trickery. Most of the textures are black and white or grayscale. So we could actually drop the GMB channels from this for most of the textures. It might be an optimization that we do in the future, but for now we can't really mess with this. The normal map, RGB, we can't really change this either, so let's not worry about that. The alpha channel, if we make it prelit, like the prelit material property, that's going to be good. This is very rarely used, so we can just keep this. We can kind of inverse the value for this. So if we say it's the inverse prelit, and then it's mostly 255 because we don't use prelit. Nothing is prelit in the world except when it is, and that's very rare. So it's going to be mostly 255, and we can just use opaque normal maps and be done with it. And then the material map is going to be a composite file. We're going to have to do some color channel shuffling on this anyway, because ambient occlusion currently is an RGB texture. I think this looks like a pretty good distribution of the color channels. I'm just thinking, this is always used. We always have ambient occlusion. Albedo mix is also, as far as I know, often used. So maybe we want to do it like this. Shuffle the channels around a little bit. Albedo mix is going to be used a lot because, as you already see, we want to change the albedo of the nails on the wooden planks. We have ambient occlusion on like every texture. But I kind of want to keep these together because that's the way the engine currently orders properties. So let's keep like, is metallic, do we change that a lot? Let me think on this. So we use it a lot on nails. We have nails on things. I think we have a lot of textures with metallic details on them. But if we have metallic details, we're going to use roughness almost equally much. So these are kind of tied to each other. If we use one, we kind of always use the other, because if parts of a texture are metallic, we mostly want to influence the roughness as well. And that's also tied with the albedo mix. But then the question becomes, do we want to move the ambient occlusion over to the normal map? Since this is never used, it's sort of, this is, thinking about things is also a good idea, because we can optimize things for ourselves. So we could say ambient occlusion, we move it to the alpha channel of the normal map. This is like a pain for all of the textures we currently have, because we have to make this a composite file as well. But it would simplify our metallic map then. And if we don't use albedo mix for a texture, how often do we use albedo mix? Quite a lot, I think. Most textures are do have some parts to them that want to be a specific color. I'm thinking maybe we can find a way to have only 2 maps for most materials, and then we only have a material map for the more intricate materials, but maybe we can't optimize this at the moment. Maybe we just have to run with something and say, like, we tried our best. We tried our best. It takes a lot of brain crunching here, so bear with me as I think this through. Let's revert. Let's say that this makes most sense. This way we can keep the production of the normal map and the albedo map very simple, and then the material map is going to take the most time because it's going to be a composite file with all kinds of stuff going on. But maybe that's just the way it is. Maybe we move the ambient occlusion to this channel, because that's always going to be, yeah, this is what we're going to do. Because we can draw roughness, we can draw metallicness. This is what we can actually draw in Illustrator. It's very simple to do. But the ambient occlusion comes from Pixplant. That's an external texture that we get. So let me show you. We make, in Illustrator, we make a displacement map like this. And then we get a material, no, that's the wrong one. This one. So we use Pixplant. It's a texture tool that has ambient occlusion, ray tracing sort of built in. If you offer it a displacement map, like how high are all of the parts of the texture, it will actually calculate the ambient occlusion for them. We're going to get an external file for this anyway, so we're going to have to do some trickery to apply this to our other material texture channels. So we already have to do some trickery for this file. So let's make it the most tricky file. We're going to use this for every texture, so it's going to be an involved process anyway. So let's make the rest of it as simple as possible then. I think that's the trick. And this means that we do have to have all 3 textures for most materials, because we're always going to have a color, we're always going to have a normal map, and we're always going to have ambient occlusion. That's just the way it is, I think. If it doesn't work, we'll have to redo all of the textures, but that's easy. We can redo all of the textures. We're going to be redoing all of the textures anyway. So this is what we're running with, I think. Sorry. So we have this working, this works already. We have the normal map RGB already working. Now we can kind of like this prelit thing, like I said, we don't have any current support for it. So if I open up the shader file, there is a prelit factor, I think. No, there isn't. There used to be one, but there isn't anymore because of reasons. It kind of, I think if we open up the generic vertex shader, let's see. Yeah, we assume it's passed from the render vertex in a different factor. So I also updated this file. It's the render vertex header file. As you can see, this is the data we supply per vertex. So it's kind of similar to the material mapping that we just described. We have a position XYZ. We have, well, one moment, I'm going to press a button here because I can. It's how we do it, yeah. So a vertex has a position, the shader flags are internally used. We have RGBA colors per vertex, we have an albedo map coordinate, we have a normal map coordinate, we have the surface normal at the vertex itself. I added these normal map orientations, so this is to flip the normal map when we use it as a mirrored face or on a mirrored face. We have lighting direction, which we set up in the first live stream. That's the amazing part for directional light everywhere. We have a shadow factor and then light factor, so this is kind of affecting the shading of the vertex itself. Then we have ambient occlusion, metallic, roughness and prelit, so we do actually send a prelit factor. Take a look at the order of these, so ambient occlusion, metallic, roughness, and if we take a look at our material map suggestion, we actually mix them around, so we have roughness, metallic, albedo, ambient occlusion. It's kind of like the completely opposite order. So we could ask ourselves, do we want to change it over here so that they are in the same order, and it makes things a bit more internally consistent. Sounds like a good idea. If we're actually going to run with this, we might want to update the vertex layout accordingly. But that's maybe not something we do today. Today we can just implement this independently of what the vertex is laid out. And we do send over the material map coordinates, so we're going to be able to use our material map anyway. I think it's time to draw one. We're going to draw one for the wooden planks. I think that's like the best idea that I have currently. And we're going to see if we can make the wooden planks look good. Yeah, let's do that. Right, so let's minimize Xcode for now. I'm going to keep this texture channel thing. It's on my desktop. We're going to keep this in mind. But what we're first going to have to do is define what the material map itself will look like. So I want to be able to the inverse prelit material, and this is going to be an absolute value. So let's make this a bit bigger so everyone can read along. We kind of have to decide the way that these channels operate. And I think roughness is going to be relative, so that's going to be relative -0 to plus 1.0, so that we can actually decrease the roughness of parts in a texture, but we can also increase the roughness of parts of a texture. We already saw with the cinder blocks and the wooden planks and the roofing tiles, we want the background to be more diffuse, so we want the background to be rougher in a sense. So we want to have a way of positively influencing the roughness value. But on other textures, we want to add a metallic part. So the wooden planks are the perfect example. The background is going to be more diffuse, but the foreground of the wooden planks is going to be less diffuse. It's going to be more specular, more smooth, so less rough. So in the wooden planks texture, we kind of want to influence the roughness in both a negative and in a positive way. So we have to do this relatively. So the texture pixel is going to have a value from -1 to +1, and then we just add or subtract that in the fragment shader. Metallic, I think it's the same deal. I'm thinking we have metallic textures that need to be less metallic, and we have non-metallic textures that need to be more metallic in parts. So we're going to use the same system for this. So we kind of get a sort of symmetry going on here. For consistency's sake, we can actually switch these around. So that makes, like if we do metallic first and then roughness, we approach the way that the engine works a little bit better. I like this. And then we could also say that the albedo mix, that we move that one to the front. Albedo mix is going to be absolute. It's going to be a value from 0 to plus 1.0. And it says, do we want albedo mixing or do we want to have albedo override on this? So this is going to be the red channel, green channel, blue channel. And then the ambient occlusion is absolute. We get this from PixPlant, but it ranges from 0.0 to plus 1.0. Let's try to align these. There we go. And then this is the inverse prelit property. And that's going to be absolute. 0 to plus 1.0. And it's mostly 1.0. So maybe we should inverse this. So it's going, a value of 0 is going to mean 1. And a value of 255 here is going to mean 0.0. Makes sense? It makes sense in my head. So that's cool. Looking at this, I think this is the best distribution of channels that we can start working with. We don't have to update the albedo map. We don't have to update the normal maps that we have because we didn't draw any that have prelit applied to them. So maybe we call this emission. Emission is a more natural term for radiating light. So let's call this emission. We could also call it radiance, which is the term that shaders use a lot as well. But let's go with emission for now. It's light emission. And then the material map has the albedo mix. It's got metallic, roughness, and ambient occlusion. And 2 of them work in absolute ways and 2 of them work in relative ways. I find it always best to have a plan before you start working, because otherwise you just have to redo parts if you don't pay attention, if you don't think things through beforehand. So let's go with this. I think it's going to work pretty well for every texture we have in the game. We already use the material map, so like optimizing to condense all of this information into 2 textures and like 8 texture channels is probably not going to work, because we always want ambient occlusion and we kind of always want albedo mix. So most textures are going to have 9 channels. We can't cram those into 8, not at the moment. We can optimize this later. We can write some texture tools for this. Hey Alexi, how are you doing? So this is what we're going to run with. This is the way we're going to implement the material mapping. We're going to draw these textures today. We already have these, so we're going to draw textures for this. We already, of course, have ambient occlusion, but now we're going to add albedo mix, metallicness, and roughness. Now, textures where we do not have this defined just yet are going to look absolutely horrible. They're going to look miserable because of reasons. Well, because of the fact that we like mix channels now, and maybe we just redraw all of them at the same time because we don't have that many textures defined. I have 2 texture maps now, so we have the regular materials and the block decorations. So we have 1, 2, 3, 4, 5, 6 textures already defined. And let's see, in the block decorations we only have the rocks, I think. Yeah, so 2 rocks with albedo, material, and normal mapping. So it's 8 textures that we're going to have to draw first, and then we can add support in the engine. And if we do it right, everything is going to look amazing first try. So we can do two things. We can either focus on one texture first, implement material mapping, and then do the other textures. Yeah, so maybe let's do that. We're going to do that plan because we want to have results first, or as soon as possible. So we're going to have to draw a material map for the wooden planks. Here we go. It's going to be simple. Famous last words. So we have a displacement map. We do want to keep this to make the ambient occlusion map in PixPlant. And I kind of want to start subdividing these folders because right now we're going to get a lot of files per material. So this is wooden planks variations is actually the thing that we pass to texture packer. So condensing all of the PNGs in this location is a good idea, I feel, because it makes it easy to see which textures are in the texture sheet. If I open up the regular texture packer sheet. So as you can see, cinder blocks variations, wooden planks variations. It makes organization in the texture packer tool a bit better. But I do want to, like I made an archive folder for the old Pixplant version. I kind of want to make a folder per texture file that we have. But how are we going to name this? Because we need a name that is in between the A and the W here. And it has to be as close to the AR as possible. We want it to lexicographically sort nicely. So art. Art is very close. Yeah, maybe we can use art as a start and then say wooden planks. Yeah, there we go. I kind of like this. And then we move all of the wooden planks files, these, and the displacement PNG. Those four, we move it into base art. Base also sounds good. Base wooden planks. And then we call it base wooden planks pole. And that already has 6 files or 8 files in there because it's got a pole. The pole texture has got the side to it and it's got the top and bottom part. So let's move it over there. There we go. So this already cleans things up. And as you can see, if we open up the wooden planks, we now get a very manageable set of textures. We're going to add 2 more to these because ambient occlusion is going to be one of these. And then we have the material map. So we're going to have 6 files per texture, and in the case of a column block, we're going to have 12 files. And 12 files are still very manageable because they fit into one single window. So how are we going to call these? Like base and then long dash wooden planks. I kind of like it. And the archive, you kind of want to name this ZZZ archive so it's at the back. But let's not do that for consistency's sake. I usually call these archive. So, okay, I like this new organization. Then we're going to move the ambient occlusion maps because we want to use them for a different purpose now. So we're going to move, this is the ambient occlusion map. It's currently called material, but we're going to move that to the base of the wooden planks. And let's rename it as well. So, wooden planks, PBR, ambient occlusion. There we go. So that's our 5th file now. We do the same for the column blocks. So let's see. This is the variations folder. This is the pole. Let's get the ambient occlusion, this one and this one. Let's move those over to the source folders now. And we rename those as well. So this is going to be the wooden planks, pole, additional PBR, ambient occlusion. I don't like typing ambient occlusion everywhere, so let's call it AO. And this is going to be the wooden planks pole PBR AO. This is the side of the block. Right, that's good. And then we rename this wooden planks folder as well. It's in the base. Wooden planks PBR AO. There we go. Yeah, the AO is much cleaner. And maybe the caps, do we want AO like this? No, it's a... There we go, AO. Right, so now we're going to have to draw an albedo mix channel, a metallic channel, and a roughness channel for the wooden planks. We can close this folder. I think we want to use the albedo as a base because this defines all of the separate parts that we already have. So let's copy this over. And let's call it wooden planks PBR material. So this is the name of the stream, right? Material mapping. We're going to draw a material map here for the wooden planks. We have different channels. It's going to be a bit involved because since some of these channels operate in a relative way, we want to have like metallic be neutral in most parts of the texture, which is 0, 0. But it's going to be a bit hard to do because, so for relative mapping, our texture value is going to be 0 to 255. It's going to be 8-bit. It's going to be a byte. And this 0 to 5, that maps to, let me space a lot here. For relative values, that's actually going to map to from 1.0 to plus 1.0. There we go, from minus 1.0 to plus 1.0. So what's the actual 0 value going to be? So 0 is going to be 0 plus 255 divided by 2. And that's 127.5. There you go. Now, how are you going to represent this in an 8-bit value? We can either do 127 or we can do 128, which is not ideal. But then we can kind of like deduce most materials are going to be non-metallic by default, so we can err on the safe side. Or we can even go with -0. I mean, the planks are not going to be metallic anyway. Right? So our 0 value is going to be either 127 or 128. That's what we have to keep in mind. We also have this albedo mix, and we need to take a look at what looks good. So in the current game engine, most of the materials have a very neutral gray shade in the back. Right now we don't copy that property. We have to tweak. We have to tweak and we have to find something that looks good. We can't, like, in theory, things are going to be different than in practice. So we want to make something that looks good. So first of all, albedo mix, let's put this to 0 for almost all of the parts, except for the nails, because the nails we want to be gray and we need to define what value of gray that's going to be. So we might have to update the albedo map to match. Let's look at what steel is usually colored like. So that's material shading values, sorry, material color information, we were in the right file. Steel, metal, steel, here we go. Steel in the engine is defined as a gray color from 0 saturation. Okay, so it has no saturation, it's actually completely flatly colored gray-ish. And then the value ranges from 37.5 to 85. I'm just reading this aloud because you can't really read it. So if you take our calculator, 37.5 plus 85 divided by 2, our average steel value, lightness, is going to be 61, sort of. So we need to update the albedo map to match that. Let's select all of the nails. That's all of the nails. And then we go into hue, saturation, brightness. And then we have to set this to 61. Otherwise the nails are going to be a bit too bright. There we go. Save this albedo file. And we're happy. We might also take a look at the background already, but we're not going to do that. We're just focusing on one aspect first. Let's get a good material map going first. Right, so this is back to our material map. The nails, this is the easy part. The nails are going to be metallic, so we can set the green channel. Bear with me, we're going to set the albedo mix to 255 because we want these to take over the color from the texture. So we go back to RGB mode for this texture. 255. We're going to copy the albedo from the albedo map. We want them to be metallic, so this is going to be plus 1.0 anyway, no matter what our base value is. So this is going to be 255 as well. So the green channel is going to be 255. Let's go. Right, so that's cool. And then we have the roughness. So now we have to compare roughness of steel and wood, because wood is our base material. The steel is what we're going to override here. Let's take a look. Steel is shading values, roughness, steel is 0.15, and wood, base wood is 0.75, and painted wood is 0.3. So we're going to have to subtract a little bit from this. And let's say we just subtract to 0.15. So we have to calculate minus 0.15. No, sorry. Are we empty? Yeah, we are empty. Minus 0.15. That's the value that we have to encode here. Times. No. Minus 15 plus half times 255. There we go. our value is going to be 89. It's a bit involved, like I said, but the 89, there we go, that's the blue channel. So we end up with this very weird looking yellow color, but again, it's too bad that Illustrator hides this dialog, so maybe we can open up the color picker like this. Here you go. Check out the material map for the nails here. We have on the red channel albedo mix, so do we want to multiply or override the albedo color from the texture? And that's going to be 255 here, the R channel over here, R, 255. So we're going to copy the color from the albedo texture instead of multiplying for the nails, because we want them to look gray, steelish. The green channel, metallicness, is going to be plus 1.0, so that's 255 on the green channel over here. That's good. And then we have roughness. And the roughness is going to be a little bit lower than what the base material has, so the nails are a bit more shiny than the wood that they're hammered into. So that's going to be minus 1.15, and that kind of encodes to the value 89. Does that make sense? We can kind of like check this. Hey Song, hello. We can kind of check this because maybe I'm off with my math. Because this value feels too low. Maybe it is minus 0.15 plus 1 times 255. No, that's too high. No, this is not correct. I think my original calculation was good. Because if we do minus 1 plus 0.5, no, it's not good. Dude, what's happening? How do we encode this relative value? Metallic is simple because we can just say plus 1 anyway. However, we have to have the value, I think. Minus 0.15 divided by 2 plus 0.5 times 255. 108. There you go. This is going to cause a lot of headaches in the future. Maybe there's an online tool for this that we can sort of abuse. So convert. Now, we trust our instincts here. We trust our instincts. 108 is going to be the right value. Because if we decode it back, 108, we subtract 127.5 from it. So that's minus 19.5. And then we divide by 255. And then we end up with minus 0.7. Okay. Why is this so hard? That's what she said. More math. So minus 1 is always going to be 0. Maybe we can... What? You were practicing piano. Okay, I'm practicing my math here because I'm not seeing the light here just yet. We need to find a way to encode this entire range into 0 to 255. Okay. The midpoint is going to be 127.5. I can live with this. I can completely live with this. This is entirely what we want. But how do we encode minus 0.15? So we now have a value, and how do we encode this? Calculator. Minus 0.15. Minus 0.15. There we go. Maybe we just multiply it times... It's going to be the midpoint. We're going to subtract it from the midpoint. So 0.5 minus 0.15. Is that what we want? No, this can't work either. Okay. This is nice. This is exactly what we wanted to do today. Worry about math and all of this stuff. Dude, why can't we figure this out? Is my initial guess good? Or what? We need a spreadsheet or something. We need to figure this out. Let's open up numbers. If it actually works. Yeah, I like it. I'm going to create a spreadsheet. Yeah, there's no reason you have to connect to the internet anyway. Tips. Yeah, super helpful. Thank you. Right, so we have a few values. Let's say we have -1. We have -0.5. Why are these not formatting as numbers? -0.5, okay. We have 0, +0.5, +1. And then we want to have a formula that maps these correctly. So 0 is going to be simple, 1 is going to be simple, like we want it to be. This is the value, want it to be, formula. Here we go. We can hack this. We want this to be 0. We want this to be 127.5 sort of. We want this to be 255. And then these are going to be in between. So this is going to be sort of like 64 and this is going to be sort of 192. Hopefully we can agree with this. And let's format these as numbers with 1 decimal. All right, here we go. Our formula. I don't understand anything, don't worry about it. We're mapping floating point values to integers here. It's simple. I only struggle because I am struggling with this. So we can already see that it's going to be very simple. It's going to be, we want to take the actual value. We're going to take 1. Then we add the value that we want to encode. There we go. And we do that times 255. Boom. Check it out. Nope. No, okay. So we do this times 127.5. We're just, this is not mathematically, it works. It's exactly what we want. It's not super duper, super whatever. So this is a relative value calculation. Right, so now we add 1 row here. We have a formula that works and now we can add our custom values over here. So we have -1.15. That's what we wanted. So the value is going to be 108. There we go. And we had 108. So our second formula, I did it correctly actually. But let's make this row a bit bigger. Bigger numbers. So we can use this as our calculation in the future. So we're going to save this to the desktop. Material value calculator. There we go. Super cool. Let's remove the bar and we can make it a very tiny spreadsheet. Hopefully the numbers saves the window size. Yeah, there you go. There you go. All right. So we have a super cool value calculator. So if something has to be plus 0.5 roughly, yeah, that's actually correct. 23. There we go. Now we're talking. Now we're talking. It's cool. This is exactly what we want. So we know for the nails we want them to be a little bit less rough. So 108 is exactly perfect here. Right. So now onto the rest of the texture. The ambient occlusion we're going to mix in later, so that's for another moment. So next up, the rest of the materials. How are we going to approach that? Let's say that we want to keep everything as is for now, so we're going to go with we want the albedo mix to be 0, so that's easy. The red channel is going to be 0, like this. Then the metallic portion isn't going to change, so that's going to be relative, but we want to err it on the low side, so we say that's going to be 127. It's unchanged, but it's on the bottom side of being metallic. That's cool, sure. The roughness is going to change, isn't going to change, and that can err sort of to the lower side as well. So let's say 127 for the blue channel, like this. And then we have to copy this color 0, 127, 127 to the the parts that are... Basically, we can just throw everything away. That's the idea. Let's revert this. And let's just hide this layer and use the background layer for this. No metallic, no albedo mix, no change in metallic and in roughness. There we go. This is what our base material map looks like. So the nails stand out and we're not doing anything with the background at the moment. So we're cool with this. This is what our material map without the ambient occlusion just yet looks like. And now you might say, how are we going to add the ambient occlusion to this map as well? Because we want to have that in there too. So this makes sense, right? The nails stand out because we're going to do special things with the nails. We're going to copy the albedo, we're going to lower their roughness, and we're going to increase their metallicness. So that's why this is colored like this. It's the RGB channels applied to... it's the RGB channels used for the material mapping. This is what we do. This is what I live for. This is what we live for. So this hint is useful, but it takes up a lot of space here. Let's remove this line over here, so we drop the scroll bar. Alright, cool. We're not going to do anything with the emission just yet. So this is the material map. Now we just need to use, now we just have to get the ambient occlusion into the alpha channel. How are we going to do this? I think we're going to save this file. So we save this as material map. Material in the base wooden planks. Here we go. I don't really care about your file name characters or whatever. Okay, so now we're up to 7 files per material. Don't worry about it. We'll figure this out for the future. So now we have this material map, we have the displacement map, ambient occlusion map. We're going to have to mix these two together. So as you can see, the nails are in the exact same spot, so that's good. We're going to have to mix the ambient occlusion into the alpha channel of this file. And I think we can't really avoid having to make a separate file for this. So let's make a new texture file. We use 480 by 480. And then we place the material map. We're going to place, but this is an easy step. This is easily done. Place the material map in here. So as you can see, it's centered. This is the material map that we know. Then we add transparency to it, like this. And we place the ambient occlusion map into the transparency. Maybe this works first try. Boom, there we go. Mixed together, check this out. As you can see, the ambient occlusion now kind of affects the transparency of things. Don't worry about this too much. I think this will work. So let's save this as wooden planks. Not a material PNG. What do we call it? Material final? We have to rename some things because the names don't make sense. This is actually not material, but let's call this properties. It's too long. Props. So we have AO and props. Wooden planks, props. Material is actually the term that we want to use here, but how do we call the final composite? Do we call it base? Wooden planks, base, props? What's a good name? I said in the first live stream there's two big problems in computer science. It's caching and naming things. But how do we have roughness, metallic, and albedo mix in here. So what do we call this texture? It is material properties, but we can't call it material. So what then? Base sounds a bit weird. Let's open up the dictionary. What's a synonym for material? Here we go. Matter, substance, stuff, medium, constituent, raw material, element, components, items, articles, stuff, clothes, textiles, data, facts, facts and figures, statistics, IDs, details, info, dope, what? The lowdown. Okay, yeah, sure. I don't want to call it stuff or something. Let's call it base then. Let's go with base. I can live with this. Then we probably have to relink this file because it's been renamed. Link it to the base file. Boop. There you go. And then we can save this Illustrator file as material. Yeah, so Song, this is a very technical, very involved live stream. It does involve drawing things and making things. So future live streams might be a bit more accessible. All right, here we go. So we have the ambient occlusion applied to the alpha channel now. We have the material map looking good. So let's save that to the new material thing, wooden planks, variations, wooden planks, albedo, normal. Yeah, we just put it right next to these. Open up texture packer, let's see what it looks like. Okay, so this is our new material map. As you can see, a huge difference compared to the single ambient occlusion map. You know how to draw. Okay, cool. So we kind of have to make these, like we have to replace the other ones as well for the column. So these are going to be different. Are we going to do this? Yeah, we're going to do this. We open up the albedo for the side texture now. The side texture, wooden planks, pole, albedo. Okay, so here we have the same trick. We're going to save this as base now because that's apparently the name we use for this. We can hide the plank. We have the nails and we select all of the nails. We want these to be, what did we use? 255, 255, 108. That's exactly the color we used in the other file, right? Because these nails are going to be looking the same way. So let's open up the base file here. The nails, 255, 255, 108. Yes, that's cool. And then the background we used, see, we're already gaining steam here. This is going to be much better. 127, 127, 255. Nope. We used 0. Nope. We're going to cheat here. What did we use and why? 0, 127, 127. And we used 0, 127, 127 because, oh yeah, we don't want albedo mix, but we do want neutral, metallic and roughness. And on the low side of both. Okay. 0, 127, 127. Sure. We have to save this. Do we have to save this? Yeah, we save this as a... what is the size of this texture? It's going to be 480 high, 224 wide. Okay, cool. Save this as a PNG here. Boom. You can close this one. We don't need it anymore. So we have the base for the side, and now we need to create the material map out of that. So let's create a new file. 224, 480. We place the base. Place the base, flip the script, and then we apply the ambient occlusion as alpha channel here. Ambient occlusion, AO. Right, so now we're back to something that kind of resembles what we had for the other texture. So let's call this the material, save it, export it. The size is 224, 480. These are numbers specific to the game engine that we use. If all goes well, yeah, we now have the new material texture for that material in there. And then next up, we do have to make a new material map for the top side of the column, and that's going to be this file, albedo. Right, and we basically don't want to do anything for this texture. That's the easy part. We don't have any metallic portions, we don't have any albedo mixing going on here, so we can just hide this top layer, and we can go with the 0 albedo mix, and then low end of the spectrum, metallic and roughness factors here. There we go. So this is going to be the base texture. And a lot of textures are going to look like this, I think. So maybe we can optimize this out. I think Texture Packer will optimize this out. So these are just going to be plain textures saying like, okay, there's nothing going to be applied to this. So we could also optimize this. So instead of having a base texture here for this top part, we can just remove this layer. We can basically just remove this entire texture. Here we go. Except we're not going to do that because of reasons. There might be some future additions that we want to keep in here. So this is going to be 224 by 224, and we are going to save this base PNG file, save it, and make a new one, 224, 224. Bear with me for a moment while I place these textures. Like I said, the size or the dimensions of these textures is specific to the engine and the way that things work in the engine. So don't worry about those numbers too much. We're going to apply ambient occlusion to the alpha. Here we go. Looking good. And we're going to save this as the material texture. It already exists. Because displacement. It shouldn't already exist. Oh, we named the other one incorrectly. These things happen. These things happen. Wooden material. Where are you, Marshall? This is not the additional, this is the PBR material, like this. And then it's probably named incorrectly here as well. Yeah, it's called additional here. We're going to have to save these again. Hey, the cat in the box. I like the cat in the box emoji. Thank you. Save this. Additional material. Boom. Save. Export this. The size is good. We overwrite the file because we'll export the other one once more. 224 480. Blaze it. There we go. Right. So we now have a new material map for the wooden planks pole, the top side of it, and the wooden planks, the full block. So it's an involved process. It took us about, what is it, half an hour or so to do this for these three textures. We had to do some math and we had to figure things out for the first time. It's probably perfectly fine to use this process for textures in the future. Let's see what our naming, if our name is good. So we have the additional PBR, AO, the base, displacement, the material, and the normal. Okay, that's good. That's 6 files. And we have 2 PNGs. We have 2 PNGs for these, and we have 6 files for the other one. Okay, so instead of ending up with 12 files, we now have 16 files. So we get 8 files per texture, but it's all cool. Like, if that's what we have to make and have to use, we're just going to run with it. We're going to run into a major problem, I think, very soon, because we're loading these PNGs in a weird way in the engine on macOS. That's going to be a problem, but we're going to see what the results look like first. So let's write the sprite sheet. We're going to go into PBR, and we're going to use texture converter, our internal tool, to convert these. So I think I'm going to have to add 1 to 7, and we're not going to matte the texture anymore, so we're going to make a proper transparent texture here. Matting is the process of replacing alpha with a certain fixed color. And I used 127 here because otherwise these areas would go weird. So I think we're going to end up with albedo mixing going on everywhere. Our texture converter tool isn't the best at the moment, or it has this weird problem on macOS. We're going to have to wait and see what happens with that. We might have to rewrite this interactively, and I'm not looking forward to it, but hey, what can you do? I don't think the code generation is going to change anything because the textures are still in the same position. They're still named the same. Okay, brace yourselves, this is going to look ugly.
Oh, no time to waste, let's go.
Yeah, it's like I said, it's going to be ugly because we changed some color channels around, and this is what we end up with at the moment. Sure, we're running with this and we're going to debug it, and we're going to make sure that things look great once we are done. Hopefully. So let's open up the fragment shader, pbr.frag. This is where we actually shade the pictures. So we didn't change any of the vertex definitions because we might want to have those match the order of the texture itself, but we're not going to worry about that at this moment. We have our nice texture. So basically, I'm closing Illustrator because we know that these values and these textures are going to be correct. Any problems in rendering that we will see are going to be due to problems in the engine or in the texture conversion tool. So we're going to write the shader as if the texture is correct, and then we might have to update the texture conversion tool that I have to actually output something useful. So here we are going through the PBR shader, the fragment shader. This is the program that runs for every pixel on the screen. So each individual pixel that you see being rendered goes through this entire process. We already have material mapping working because we already use it for ambient occlusion. So we're going to take a look at where that is in the shader. This is the shadow map, the shadow factor. Here we have material mapping. Hey, sounds kind of like the title of this live stream, right? Here we go. Material mapping. So these are the base properties that we get from the texture. So that's from the vertex, sorry. The base vertex properties. We have the albedo, we have the ambient occlusion, which is now called occlusion, metallic factor, and the roughness factor. And it says use material mapping if available. So if we are texturing and if we have texture coordinates for this material, we do actually look up the local material map. We get the shading for the material map coordinates. And we already multiply the occlusion by the X channel. You can either call this XYZ or RGBA, XYZW, by the way. So we're multiplying occlusion by the X, the first channel of the material map. But that's actually not correct. So let's open up our design document here once more. Maybe I should keep it open, but I always like to close windows that I'm not using. And I'm also not using Windows at all. So here we go. The ambient occlusion is now on the alpha channel of the material map. So instead of using the X here, we're going to say alpha. And then we have the other channels. So the albedo mix is on the R channel. So we're going to say the albedo value is actually going to be a mix of the current albedo, which we already calculated from the vertex color. So we're going to mix it's going to be even different, I think. But let's see. If the value is 0, what did we say? If the value is 0, we're going to keep the old value. All right, so that's good. And we're going to mix it to the sRGB, to linear representation of the local texture color. This should actually be called local texture albedo or something. It's the albedo, like here, local texture color is get the shading of that. We do that in sRGB color space, I think. So maybe we already want to multiply here. But we're not going to worry about that at this moment. Let's just say we convert it to sRGB once more. And then the mix factor is going to be the local material map, the R channel. I don't really want to call these XYZ here because the textures are in RGB format, sort of. So that's more natural to call the texture channel RGBA. I'm not sure what we do for the normal map, so let's see if we have normal mapping enabled here. Yeah, so we do get the shading for the XYZ here, so maybe we also rename this to RGB because it's a more natural representation of the, like it is a shading value, it's a texture value, so it's more RGB than XYZ, something to consider for the future. I kind of like this. So let's use RGB here because we're going to use the A value of this later on for the prelit channel. Anyway, back to the material mapping. So we mix the albedo now from what we used to have to the actual texture color, and depending on the absolute value of the R channel. Then we have the metallic property, and we're going to modify this absolutely, sort of. So that's going to be plus is, because it works in a relative way. And metallic is going to be -1 to +1 in the green channel of the material map. So that's going to be local material map dot G for green. So we have the R, G, and then now we have to have the B in there as well, which is for the roughness. So roughness is going to be modified by the local material map blue channel, B. So here you can kind of see the symmetry, or sort of the layout of our texture coming through. Albedo is going to be mixed based on the R channel. Metallic is going to be affected by the G channel. Roughness is going to be affected by the B, blue channel. And occlusion is going to be multiplied or affected by the alpha channel. And that's exactly how we laid out the texture. Now what we want to do, because we could end up with super huge values if our texture defines a roughness +1 and the roughness was already +1, it's going to be a huge value. So we do some kind of influencing here already, or like limiting, trimming of the parameters. So what we want to do is limit the roughness after we do sampling as well. So maybe this we're going to say roughness blah 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 blah, that's all good, but instead of doing the limiting here, we do the limiting here. So we're going to say like limit or clip limit material properties. So the roughness, we can kind of use the same mechanism. We scale it all the way from like the lowest value is going to be 0.1. Then we add that roughness modifier to it. And now the question becomes, do we want to limit it over here or over there? We could say like the minimal of 1.0 and the maximum of 0.1 and our calculation. So we want a roughness value that's between 0.1 and 1.0 tops. And the same holds sort of for the metallic and the roughness. So let's say roughness is going to, we already have the roughness, so we're going to clip the metallic. Here we go. Minus blah 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 on the metallic. There might be a clipping function in the GL shader language. I'm not super familiar with this, but hopefully this will work. I mean, the albedo mixing is always going to be like correct, because this is 0 to 1 in the R channel, and the occlusion is going to be correct. We already had this working, so we don't have to massage that or anything. And maybe we can just set the roughness to the vertex material Z. So that's actually what we want. So we just copy over the material and then we limit it later on there. That sounds good. Let's run with this. Let's see what happens. No matching function for call sRGB to linear vec4. Okay, that's cool, because we have an alpha channel in here, so let's call this XYZ, or it's actually RGB, right?
Oh, no time to waste, let's go.
Okay, right, it's not perfect, but the thing that we have, as you can see, the nails are now gray. That's the good news. The nails in the textures, as you can see, they are now gray. Whoa, looking good. Are they metallic? We have no idea. We have probably no way of knowing if they are metallic or not. We could start outputting like a metallic value for that. The bark and all of the other textures, they are completely messed up now. Let's see if we can find a metallic reflection on any of these nails. It should work. it should work. The wood itself doesn't look too good. There's a bit of a problem going on with some of the shading on the wood itself, but we're going to fix that in a few moments. It looks sussy. Yeah, it's very sussy. Suppose we, I think things will look a lot better if we, where's my mouse cursor? Anyone see my, oh there it is. Anyone see my mouse cursor? If we don't influence the metallic and the roughness properties, maybe things look a little bit better already.
Oh, no time to waste, let's go.
Right, here we go. But what's up with the grooves? Why are the grooves... See the shading on those grooves in the wood? Why are they weirdly lit like that? What's up with that? Let's disable ambient occlusion as well. So let's see if the color mixing works first. There we go. It sort of works, but our grooves... See, the grooves are... I feel that the grooves are also being weirdly affected here. What's up with that? Like everything that reflects, all the parts that reflect, they have this weird color going on. Why? Why though? Let's disable mixing and let's see what it looks like. Maybe we messed up something,
No time to waste, let's go.
something different. Here we go. This is nice wood again. The wood is good. The wood is good. The wood is fine. So now the question becomes why are things looking weird once we enable this one? We get the shading of the vertex material map core. Okay, that's all good. And we mix the albedo to the linear representation, and we work in linear color space of the local texture color RGB. That's I think this is correct based on local material map.r. I'm pretty sure our R channel is correct, but we can check. Let's open up our material map for this one. Photoshop. Here we go. So our R is 0 here. So we keep the original shading value. That sounds good. And then here we have 255, 255, 108. Okay, I'm pretty sure that this is an artifact of our texture converter tool. If I use a value of 0 here, so that's kind of the default value for the texture, we're going to get gray nails and everything is going to look good. Yeah, here we go. So we need to tweak our texture converter tool, because as you can see now we do have the correct albedo value. So we get these metallic nails in there and they look like metallic nails, which is kind of like what we were shooting for. And all of the other parts of the texture are unaffected. So the problem with this is that the alpha channel, like transparent parts of the texture, they get modified thanks to the texture conversion tool. That's not what we want, but hey, it's the way it works. Now one question that you can ask yourself is this effect what we want anyway? Because as far as I can tell, or at least in my humble opinion, these nails, they look very, they look very bright now. So maybe we can re-enable metallic and roughness. So the occlusion is not going to work, but that's not a problem.
Oh, no,
let's re-enable this, see what happens now. I do believe that they have metallic shading going on right now. It's a bit hard to tell. You can definitely see that they are a bit darker now compared to the surroundings. Again, the big question becomes, do we want this effect at all, or is it a like too subtle detail? For instance, check out that pole over there. You can see the nails from afar, or at least I can see the nails. I'm not sure if I can zoom in. Here we go. Check it out. These nails on the pole, they are super super visible. I hope you can see this. I'm not entirely sure if the zoom function actually comes through on the live stream. But you can definitely see that the shading of the nails is different compared to the shading of the wooden material. And it's not just subtle either, it's like bam in your face. But maybe it's because we don't have ambient occlusion applied at the moment, because this is the shadow part of the pole, I think. It's in the shadow and we don't have ambient occlusion going on there. So maybe things are better than they appear. But we always should be on the lookout, like don't add too much detail that's distracting. Also here on the top part of the walkway you can also see the nails in the wood, like this. And on this side, and on this part, and over there. So that's definitely working. That's definitely working. As you can see, the nails just pop in on the columns here. Is it what we want? We can always tone it down or tweak it later. It's the way it is at the moment. These are the nails and you'll have to live with it. We could also just remove them from the texture to make things look a bit more clean. But anyway, we want this system, like independently of this texture looking good, we want this system or this flexibility for the future. So we should actually fix this. Now, how are we going to fix this? And that's a good question, Firefly. So we're going to assume that Texture Packer actually creates a good file. So we're going to assume the Texture Packer is not the problem. And I'm pretty sure that our engine is the problem. So let's open up the artwork file. Let's see what Texture Packer actually gives us and if the colors are good. Open this up in Photoshop. Here we go. So what we have to make sure is that these transparent areas have the correct values applied to them. So they have. Even though this pixel is almost fully transparent, you can see that the RGB value is 0127127. So what Texture Packer gives us is a correctly formatted texture. So that's cool. So the problem is in the way that we load or treat this PNG while converting it to our engine. So the alpha channel gets messed up a little bit. We need to do a quick hack of sorts. So let me open up, I'm not sure if the Texture Packer tool is actually installed here. Converter tool. Let's open up the texture and image tools. Here we go. Texture converter main. So this is our internal tool. It worked perfectly fine for all of the things that we've been doing it so far. So what it does, it's like this is the main entry point here. So we open up the input file and then we have this matte brightness and the matte brightness as RGB conversion thing. If pixels are transparent in the original PNG file that Texture Packer supplies us, we apply this matte process. It's the same as if we would open it up in Photoshop and say we want to actually matte the transparency. So if we take a look at this, here we are in the problematic part of the texture. If we say we don't want, or if we want to dither it to 8 bits, for instance, you have to apply a matte to it. And you can choose black or white. So you will see that the transparent areas of the texture, they get a different effect applied to it. So foreground color, they get multiplied by the matte color that you supply. It's not Matt Damon, but it's, well, a problem still. So we don't want matting in our thing here. So basically we want to remove these lines. Now of course the tool doesn't compile anymore, if it compiles at all. So let's see, texture converter from macOS, does it compile at all? I'm not sure if I actually set up this to compile just yet. It's doing things, so that's the good part. Yeah, okay, so the only errors that we get are the missing matte brightness. And that's cool, because we just want to remove matting at all. So I think we can just remove all of this code. There we go, boom, it's gone forever. And now it says, okay, we're going to load a PNG file with this certain matte brightness. But we kind of like want to get this out of there at all. We need to load a PNG file without having to mat it. So how are we going to do that? It's in the resource loader. Resource loader. So from artwork, we're now back into engine stuff, or engine tooling, sort of. This is not actually the engine, but it's actually a tool that we use. The resource loader has a load PNG function, but where is it? Load shader source, source file name, load texture data. Okay, I'm not seeing it, but that's because we actually have a specific Mac OS X resource loader instance. So Mac OS resource loader. Right, so what we do here is we load the PNG file using, let's see, the file name is over here. We make a path string, we have an image in it with contents of file path string. There we go. And then what we do is we create and clear a drawing context, and then we clear the rectangle. Okay, we make a clear rectangle, and then we force drawing context contents to the matte brightness. But this is actually not what we want. Can we just remove these lines? Because we want it to be entirely clear, and we just paint over the PNG. But if we don't do this, maybe the contents will be 0 and it will be black instead. So what we want is, we kind of want to toss out this entire thing and replace it with a proper PNG loading library. So fortunately we do have libpng included here. But am I going to compile this live on the stream? I have no idea. Documents, angel dust build, shared, I think it is called. Okay, it's not in here. Is it in the Windows folder then? It should be supplied with the Windows thing. Okay, we've got libpng and zlib. So these are maybe slightly older versions, but this is what we ship for writing PNGs. So maybe we can use the same system for loading PNGs. Because do we have a platform support? Save image data as PNG. All right, and it's virtual. So I have a sneaking suspicion that we also have Mac OS X platform support, and it saves RGB image data as PNG using some kind of convoluted thing as well. Right, and our default implementation probably uses libpng. Yeah, it's this part. This is libpng. We're diving into programming things here. So what we now want to do is to use a PNG, or we have to write a PNG loader. Why? Why are we going to do this? Isn't there a simpler way? macOS load PNG. Blah blah blah. This is not about like raw code. PNG does not display Mac Safari. This is not Objective C load PNG. Load the PNG file with transparent background to a UI image view. Sounds good. And what's the solution? How do we do it? Your primary issue is the use of UI image picker controller edited image instead of UI image picker controller original image. When getting the selected image, the edited image loses the alpha channel, resulting in black instead of transparency. Right, okay, so what I think we have to, or can do, macOS resource loader, we are painting this into an image context of sorts, and then we copy that texture data over. But we don't want to paint it into an existing image, we just want the image contents. So we have an NS image, init with contents of file path string. We have an image ref. It's a CG image for proposed rect 0, context 0, hints 0. We do know the texture dimensions, so that's good. If we have a zero-sized image, we clean it up. So instead of making a drawing context here, we kind of want to get the raw image. Like we don't want to draw the image into something. This should all go. We just want to have the image contents. So how do we get the image contents from an NS image? NS image get bytes. Do we have something like that? NS image from byte array. CG image from byte array. Convert image to hex. NS image to byte array. Here we go. This is in Swift, but maybe we can use the same sort of idea here. We have a CG image for proposed rect. Okay, we make an NS bitmap image representation. And we make using right, but this is the way to get a PNG representation, I think, because you say representation using type, NS bitmap image file type, PNG image file type. And that's the image data. But we want a raw image, sort of. But we can take a look, So let's remove all of this junk. We can also remove the matte brightness here. We don't use that anymore, and we can make the file name const. Like this. This is an unexpected journey, sort of. This is kind of like that movie that you see on the screen, on the big screen. But it's just how we're going to do it. Alright. We can go back into our texture tool now. Texture tool, because all of that matte stuff is gone. So we have to remove the parameter from this. I think the texture data is going to be const. And what does this do? So how many errors do we have to work with here? There's a few over here, there's a few over here. Apply color matte if requested, so we're not going to do that anymore. So is matted can disappear as well. There we go. Cleaning up stuff is always fun. This can go. Boop. We are not going to matte anymore, so we can just remove. We can remove this part. Like this. It was actually an artifact of the way we were loading textures anyway, so this is much better. Output is 5-bit, okay. Short circuit if we're in. Yeah, let's set this to true or false for the moment. We have to investigate what that does, but it's gone now. It's all gone. Everything is gone. At least our texture tool should convert, and our only error should now be in the texture loader. Okay, yeah, there we go. And that's cool. So we have an image reference, and we know the dimensions of the image, and now we want to create a, what was it called? Bitmap representation of it. Bitmap wrap is an NS bitmap image wrap. Okay, NS image bitmap, NS bitmap image wrap. There we go. I have no idea what this is going to look like, but we're going to write some code here. It's, how do we use this? NS bitmap image wrap from image ref. Do we just, I have never written much Objective-C, so I have no idea if this is the way you do it. Do we have any documentation for this class? Please. Okay, we have some documentation, but it's probably in Swift, so we want it to be in Objective-C. Alpha pre-multiplication and bitmap fault. When creating a bitmap using a pre-multiplied format, if a coverage plane exists, the bitmap's color components are pre-multiplied with it. It's not what we want. We don't want to have pre-multiplied alpha, but we're going to do our best to make something out of it. Image wraps, colorize, init. Okay, so we init, and how do we init it with what we have? Oh, I never wrote this language before. You have to allocate it and then init with CG image. Okay, image ref. Are you happy now? The interface type cannot be statically allocated, but we're doing it here. They're doing it here. I want to do this as well. And as bitmap image wrap CG image. Dude, how does this language even work? Anyone well versed in Objective-C? Let me know. We can take a look at your suggestions. Do I do this to the CG image ref to ns bitmap image wrap? How to create, this is the other way around. I want to, here we go. It's solved. Blah, blah, blah. Too much, it's too much. So always know the API you're working with. I really wanted to use libpng here. I'm not entirely sure like why we can't or why we don't, but we have this fancy CG image ref. So how do we get, one more time, CG image ref get raw bytes. How to get the raw pixel data from CG image. It's a duplicate. You can get the raw data by calling cfDataRef. Raw data is CG data provider copy data. And you can step through the pixels like this, okay? Stack Overflow copying, it's exactly what we want. Alright, so the raw data is CG data provider copy data, CG image data get provider. We have the image ref here. That's the raw data, okay, that's looking good. I really dislike this, but okay, don't worry about it. We create a buffer, get data, get byte, data byte, data get byte pointer, okay, and we have a length. That's cool, and then we can copy stuff over. So let's see how we do this in the old version, and then let's apply it to the new version. So let's get a side-by-side view here. We have bytes that we have to fill, and where do we get our bytes? It's the, okay, cool, that's a pointer we create ourselves. Width by height before, because we want it to be RGBA, that's cool. We loop through all of the bytes, and then we just assign int RGB. Length is +4, okay. So length is the number of pixels, I believe. No, length is, we can actually do a straight mem copy here. So let's say mem copy into bytes. This is not going to work, but we can at least try, right? We copy from buff, and we have length, but it's actually, yeah, it doesn't really matter. So we should probably assert something here. Let's make the bytes later on, once we know the length, and we just copy it over into bytes. There we go. We don't have to have this loop. We can release the raw data. We already released the image. The ref probably gets, we don't have any context or color space anymore, and we create our texture with the data. So except for the fact that it's not going to work, it should compile. There we go. Build succeeded. Now we have to build it in our own tree. So let's see, how do we do that? See, angel dust, documents, angel dust, build macOS, make texture converter. Hopefully this still compiles. Hey Kanmaike, welcome. Kanmaike, we're working on material mapping. We are trying to add a material map with material properties to textures. But I have to update my tooling a little bit because my tools were not useful for having these textures with alpha channels. So we're updating the tooling and we have to do everything ourselves here, but it's all cool. So texture converter itself will be the old version, I believe. Oh, it's built on January 14, sorry. This is actually the new version. So let's run it and let's prepare to crash. Okay, I'm digging it. It doesn't crash. And let's fire up the game. Let's see what we now look like. If it still works, of course.
Oh, no time to waste, let's go.
Okay, we're back. Here we go. This is all looking good. Now we just have to apply the ambient occlusion again, if it's not applied just yet. So let's open up the fragment shader again, PBR.frag. And where is our material mapping portion? Material mapping over here. So occlusion is like that. There we go.
Oh, no time to waste, let's go.
Do we have ambient occlusion? Let's see. I think it is being applied correctly. Yeah, also the nails are looking darker now. I believe everything is correct now. So it's a small change, but we should now have like gray nails in the wood everywhere. And they should be steel, so they should have metallic reflections. Not sure how to test that because it's a very small area. So maybe we use the cinematic camera to get real close. Or even zoom in. So let's see. We are going to assume that the sun is actually going to hit on these nails. Here we go. Does this look metallic to you? Not yet. Not. Wait for it. Wait for it. Wait for it. Okay. Okay. Not much was happening. This gold definitely looks more metallic than that. Here we have a larger area of nails. So let's see. Do they look metallic to us? Maybe, sort of. Maybe, sort of, I have no idea. The effect is that subtle. Yes, do they look metallic? Okay. I'm not seeing it, but if you are seeing it, it's cool. Let's take a look at some other reflection. Maybe we can tell if they're metallic or not. Okay, so one thing to notice here, because the ambient occlusion is now correctly applied, is that the nails are a lot more subtle than before. So I don't really mind this. I don't really mind this look. And as you can see, here we have some more. Okay, okay. You can definitely see a big difference in shading between the wood and the nails here. So it's a good start. Like as you can see, there's definitely a big difference where the nail hits the where the light hits the nail and where the light hits the wooden planks. So well, then the question becomes, do we like these aesthetics? Because it seems to be working now, and I think that my code for loading these PNG files is actually correct now, and it will save a lot of headaches in the future. So that's cool. Also, Kanmaike, check out check out the beginning of the stream. You will see the roofs looking absolutely amazing. So I believe we are working, but we can debug this a bit better. Let's say that we are just going to render the metallic version. So we're going to copy one of these debug statements. We are clipping the material properties. Maybe we made a mistake somewhere. So let's output the fragment color to be the metallic property. So we're going to use metallic here and just make it effect 3 of metallic. metallic factor. There we go. So everything that's not metallic will be black, everything that is metallic will be white.
Let's go.
There we go. Okay, so we're already seeing a problem here, I believe. We already see a problem here because, okay, that the bark is incorrectly shaded, we can live with that. The gold, these are gold blocks. Let me pick up my, these are golden grades, so this is good. The gold block should be metallic like this, that's cool. But we see that the wood itself now suddenly, all of a sudden has got metal applied to it as well, halfway there. So that's this gray shade. So we can now see, it's good that we debug this. We can now see that the wood is suddenly picking up some metallic value. And I already know why. Instead of just plainly adding this, we are actually adding a unsigned value to it. So what we have to do here is we have to take the G channel, and instead of just, let's move this out of the way. It's not an actually simple a plus is, it's actually, we have to tweak this value because it's now in the range of 0 to 1. So what we have to do is we have to subtract 0.5 minus 0.5, I believe, so that, no, we have to multiply by 2. So that it's 0 to 2. Yeah, we have to do 2 times 2. Like this. And then we subtract the midpoint from that. So we have to subtract 1.0 from that. And the same holds for the roughness here. So we can just copy this equation over and then use the blue channel. What we're doing, Ken Maaike, by the way, is we are implementing material mapping, which means that our textures, so the fancy pictures that you see here over here, our textures not only now describe the albedo, which is the color of the material, not only the shape of the material, not only the normal map, so the way that light reflects, or the direction light reflects, but we now also added a map, which is this funky green bluish color that defines like if a certain pixel in the texture overrides the material color, if a material is more or less metallic at a specific point, and if it's more or less rough at a certain point. So that's what we've been adding so far, and now we are just debugging this to make sure that it actually works as intended.
Oh, no time to waste. Let's
So
go.
here we go. The wooden planks, they now, like I said, we made a mistake in our calculation. The wooden planks are now back to being non-metallic, which is actually what we want. The gold is still metallic as a base color, but the nails, they are tiny, but you can see these white specks, right? They kind of look like stars, but the nails are now super metallic compared to the wood, because the wood is not metallic and the nails are. So that's cool. Now we're going to debug the roughness value. See what that looks like. Our nails should be a little bit less rough, so they should be darker than the wood. And that's also actually working, so they have like more gloss applied to them. See, so you can actually see that the wood is, the darker a shade is, the less rough, so the smoother it is. So the wood is a bit more rough, is a lot rougher than the nails, and the gold is very smooth, as you can see. It's very dark, so that means that it's not rough at all. And I think that that's looking good. So here you can kind of see the shading of all of the roughness values in the world. It's looking good. It's exactly what we expected. So let's remove the debug statement for now. Maybe keep it around for a bit. We can also combine these values, of course, so we can get the albedo mix, which is the local material map .r in here. Then we have the roughness on the B channel and a metallic. This is going to look a bit weird. Oh, we actually don't define this. Don't worry about it. It's going to look a bit weird, but we can now debug metallic and roughness in the same file. So everything that is, yeah, this is harder to see. Everything that is way red is very metallic. So red means metallic, and like the darker it is in the green channel is, yeah, this is not the way that you actually want to debug this. So let's go back to just a single variable here, because it makes it very hard to reason about. So let's keep this debug statement around. Let's take a look at the actual rendering now.
Oh, no time
There
to
we
waste,
go.
let's go.
The wood actually looked a bit weird just a few moments ago because it was like halfway metallic. Now we get the nice reflection from the lamp back, and we can see a huge difference between, here we go. Now you can finally see the metallic property sort of come to light here. A big difference, yeah, definitely a big difference between the highlight on the nails and the highlight on the wood itself. So it's very subtle. Like if I take a look at the rendering on my stream, so on the stream preview, which is a smaller window than the big display I'm looking at here interactively. The nails are very subtle now, but it's definitely a nice effect to have, I believe. So we can always tweak the texture back, of course, to remove the nails or make them more subtle. But this is what, given the material properties that we have, this is what metallic nails look like on the wood. So check it out, there's definitely a big change in shading. Let's hop onto this big platform here and then enable the cinematic mode with the time lapse for a brief moment. To kind of like, I have to like move the camera around a little bit like this to get a very low angle on these. And let's take a look at the sun reflection. Here it comes, here it comes. Yeah, see the nails light up from left to right? We can move the camera a bit to this side. You can definitely see that the wood is like less affected and has a different kind of reflection property compared to what the nails do. The nails definitely get this very nice highlight going. From left to right, it looks pretty good. It looks pretty convincing. Maybe we can like fill the entire screen with a single nail. No, that's not going to happen. We're in the plank now. We are the plank. That's just what happens. We can also take a look at this. Oh yeah. Take a look at the shading difference here when the lamp is actually, the lantern is reflecting in it. Definitely a lot of like difference, different characteristics to the highlight in the nails compared to the wood. I mean, both of them get lit up. That's what's to be expected. But the nails definitely have this very sharp gloss to them, and they are much darker in the areas where no light is shining on them. So I believe this is actually working as intended now. We debugged all of the values. The one thing that we should still debug is the ambient occlusion. So if you're standing on top of this, like a huge stack of wooden planks with nails in them, yeah, you could say like, is this effect what you want? Is this actually like the way you want it to look? Also, the background of the wood is still like woodish in appearance, so we could try to increase the roughness of that. But check it out. This is what we have currently for this. Let's move over to the stairs, see what that looks like. Again, these live streams, this entire PBR engine thing is an interactive journey, so I tried to make the most of it. I have no idea where we end up, but I do believe this is a pretty nice effect on the nails. If you're going to say like we use a cartoonish texture style, but we do photorealistic rendering, this is what this should look like. Do note that in the current engine the nails also have this different color applied to them, or at least it's a bit of a different shade to them. So I do believe this is something that we eventually want to add in the game. So that's cool, that's pretty cool. The game volume, by the way, is turned down quite a lot compared to the previous live stream. So if you want me to turn up the volume, let me know. I think the top sides of the columns are looking good as well. And we also have these very tiny nails here on the columns, on the lantern. Oh yeah, let's take a look at the lantern in the distance. So previously, it's still, as you can see, pretty reflective. The color contrast between the dark wood and the nails is of course a bit bigger, because the dark wood is very dark and the nails have this fixed color now. So is this too much? Like, is this too much nails in the thing? Maybe what we can do for testing, let me see if this works. For testing, we save the project. We just remove the cinder blocks and the roofing tiles and the tree bark. So let's run with just the wooden texture, so all of the other materials don't actually mess up their shading. And we have to go back to the code generation here because the texture layout has changed. Here we go, updating, compile and run this. Oh, we use undefined texture coordinates. Yeah, it's true. Let's just remove the... Is this going to be a lot of work? A ton of work? It is, isn't it? Yeah, it's going to be a ton of work. So let's remove the material definitions here as well. Or not. Maybe we just... Maybe that was a bad idea. Don't save. Let's revert. Going to take too much work to do that, so let's not do that. We want to keep things nice and easy and fast flowing. So we can still look into making a texture for the lanterns and work on the pre-lit factor as well. And then I'll have to take a lot of time to actually put things back in the respective boxes and make sure that everything works. But don't worry about it. We have the material mapping working so far. So for the metallic channel, for the roughness channel, that's all good, well and good. Like aesthetically, we could ask ourselves a question like, is this what we want? Is this too much? So let's go into the world, try to find a wonder with some metal in there.
No time to waste.
Sorry, metal with some wooden planks in there. We have Eclipsy here. Might have some wood, so never mind the shading on all of the other blocks. That's going to be incorrect until we update the textures. No wood here, no siree. I think there's one of the buildings. Oh, there's a bridge. There's a bridge over there. Hey, welcome to Eclipsy. Yeah, welcome, Obi. Right, so here you can see different wood colors with the same nails. As you can see, the color of the nails is the same independent of the base material. So in the current engine, we try to approach that, but it's not super perfect. It adds some directionality to this, so that's what I like. What kind of block is this? Oh, these are water barrels. They do have a wooden texture, but they are a bit different. I do like the directionality that these add, so you can read the shapes a bit better. But maybe the nails are a bit too bright. Maybe we should just say like, okay, it's not steel. They are not steel nails, but they are just a bit darker. Problem is, if we make them darker, check out the shading difference between the nails and the wood. It actually looks pretty realistic. If you accept that these nails are there, this is the thing. If you accept that the nails are there, and they are actually steel and they are metallic, if you just accept that they are there, then they look pretty good. They look very convincing. One thing that we could do is to try and turn down the roughness property a bit more so that they have a bit sharper highlight. Other than that, I feel that it's very convincing wood with nails in there. This is what it would look like in real life if you didn't paint over the nails. So I believe that's the thing. If you accept that the nails are part of the wood, then it's looking good. I'm not sure if this interior over here has a lot of wooden planks, but we can take a look. It's going to look absolutely scuffed with some of the textures. It also offers a nice difference between artificial wood and, for instance, the tree bark. The tree bark looks completely bad at the moment. We can quickly make some textures for the other materials, of course. But I think it would add some visual interest in having wood where no nails are applied and wood where nails are applied. So let's see, which materials do we have? Like, what do we have? We have cinder blocks. So how hard is it to make a texture for those? It's probably very simple because we have just the base color with ambient occlusion applied to it. So maybe we just, like, we know the thing works so far. So we didn't take a look at the emission just yet. That's something that we can do later on. But we can make base textures for all of the other materials real quickly. And we can also reorganize these folders. So we call it base cinder blocks large. At least I think, yeah, we used the base for this. So we move the base textures into that base folder now. and we create an archive folder for the PIX plant test that we did. There we go. Cleaning things up is always a good thing to do. Then we are going to overwrite this material texture. In fact, we're going to copy it and we call this one ambient occlusion. So that's a PNG that we have now, and we can now create a very simple base map for this. Bear with me as this is 480 by 480, it's a full block. There we go. We just jam it full of the one value, so we know that we have 0 albedo mix for this at the moment, and we do want roughness and metallicness to be unaffected and near the low side, the low end of the spectrum. So this is a very simple material map. That's why I think we can quickly hammer these out. And we call it base because we do. And then we make a new file. Yeah, so here's the deal. We can probably, already we start optimizing things. We can probably remove the PNG files in between if we just stick to Illustrator rendering, because we can place the Illustrator file, I believe. We can just crop to the media box. Yeah, that's what we want. All right, so here we go. We can just stick to Illustrator, and then we apply the ambient occlusion as alpha, which is this file. Boom, there we go. Move back to this channel, save it as the material file, and save this as the PNG. It's 480, 480, that's exactly what we want. And cinder blocks variations, overwrite the file. There we go. This is the updated material map for the cinder blocks. So already we're optimizing the process. Instead of 8 files, we now have 7 files per texture, so that's good. We can go back into the wooden planks and optimize this as well. So instead of having 8 files here, we can remove this PNG file. But we need to pay close attention if it's actually going to work. So instead of having the PNG over here, we actually relink this to the the base Illustrator file, and it shouldn't change in appearance. It doesn't change in appearance, so we can actually remove the PNG file here, save this, and just for testing to make sure that everything works, we're going to overwrite our final PNG for this. So that's cool. One file gone. In the wooden pole, like, we can remove 2 files here. We can remove these PNGs, but let's do that once we get to it. So this is the additional, we replace this PNG with the Illustrator file, which is called base. And again, it doesn't change in appearance, so that's a good sign. The file, the dimensions are still the same. We overwrite the PNG. So this one is gone. Cleaning things up always feels so good. And then this material file, we'll relink this from a PNG to its base Illustrator file. Boop. Bada bing, bada boom. Still looks the same. Image size is good. Save it to the final PNG folder. Okay, so that's just a bit of a sidetrack here, but it saves us from having to make 2 more PNGs. So instead of 16 files, we now have 14 files here. So the cinder blocks are done. And we can quickly check, because maybe we have a wrong assumption in here. But if all goes well, it should now look good. Here we go. Bada bing, bada boom.
Oh, no time to waste, let's go.
Yeah, our cinder blocks are back to looking normal, as you can see. And by normal, I mean absolutely amazing. Ambient occlusion is still applied. Yeah, looking good. Looking mucho bien, bienu. Muy bien here. Roofing tiles is something we want to do. For the roofing tiles, we can actually do a trick. So we can actually, let's do it in two phases. First, we're going to create a material map, and then we're going to do the roughness thing, so that the in-between portions of the roofing tiles are a bit less specular than the rest. So let's create a folder base roofing tiles. move all of these in there. So we have 4 files and we want to move this up to, or want to move, we have to get 7. We copy over the material and we call it ambient occlusion, AO. It's a PNG file. Displacement is what we still want to have. Then we are going to create a base map for this. So we can do it in 2 phases or we can do it in 1 phase. Let's do it in 1 phase. We're just going to speed run through this because we can. Alright, so we have the tiles, and the tiles are going to be like unaffected by anything. This is like the base material that we want to have, so we don't want to have any, like 0, we don't want to have mixing with the albedo, and we do want them to have the base roughness and the base metallic value at the underside of the spectrum. Now the background of the roofing tiles is going to be more rough. It's going to be a lot rougher. So we don't want to have albedo mixing for this just yet. It's something that we can look at in future live streams to make the background of all textures blend into each other. The G channel is that the metallic or is that the roughness? G is the metallic, so the metallic we don't want to change. We want it to be 0 and remain 0 at the bottom side. And now the roughness, we want to increase the roughness a lot for the background of the roofing tiles. You'll have to rewind to the beginning of the live stream to see what the roofing tiles look like with the corrected normal map and normal mapping in the engine. So we're going to want to increase this. I'm not sure if we want to increase it to the max. So do we want to go with 1.0? That might be a bit extreme. But if we take a look at the values, roofing tiles are at, they have a custom value, I think, roofing tiles. Materials, tapered materials, we're going to have to look at those. Tapered materials, roofing tiles, let's look for roofing. Read roofing, roofing tiles, black, here we go. They have the roughness factor of tiles, and the tiles, it actually sounds logical, 0.2. Okay, so we kind of want to go to a stone or wooden background. So stone is at, stone cinder blocks, bricks are 1, concrete is 0.75, some of our wood is 0.75. So we kind of want to add 0.55 to that, so 0.5. We're going to know that the value is going to be around 192, but let's open up our calculator application that we just wrote. I'm calling this an app because it isn't, but it's like we want to have plus 55, 0.55, from 0.2 to 0.75. There we go, 197.6, so we can go with 198. And we're going to assign that to the roughness channel, 198. There we go. So what's going to happen is the roofing tiles themselves are going to be similar to what they were like, but the background of the roofing tiles, which is a lot darker, is also going to be a lot rougher. So you won't see the specular highlight on there as much. So that's our new base texture. And I'm not sure this is not sized correctly, but we can see if our process allows us to fix this in one go. So let's close our calculator. We don't have to save the changes. We now have the base, and now the 7th file is going to be a new file, 480 by 480, where we place our base. Just like that, crop to the media box, and then we can scale it 480 by 480 here. Maybe lock this for the future. Center it on the canvas, so that's exactly in the right spot. And then we apply the ambient occlusion map to this. So already, as you can see, the first texture that we did took a lot of time. We're now speed running through these. It's going to be not much of a problem in the future. We call this material, and we render it out 480 by 480 to the final variations. There we go. You can see some interesting shading going on now. So there's different shades of this blue going on. And the more textures that we make, the more interesting patterns we're going to see. But this is a combination of having the ambient occlusion and the material properties themselves affect each other, or at least combine in one texture map. So looking completely different here, and that's good. So let's take a look at what this appears like in the engine. If all goes well, the roofing tiles are still very shiny. They have veneer on them. We simulated the fact, but the background is going to be looking more like stone, as you will. So here we go. Still very shiny roofing tiles. There you go. And you see the in-between part is a lot less specular. So maybe we can go even lower. So I believe, or I feel that the specular highlight behind this is still a bit too much, too strong maybe. But let's take a look if our values are actually correct. So let's debug the roughness for this, because I can tell great stories here, but maybe I'm completely wrong. So as you can see, it's working the other way around, apparently. Something is not right here. Our roughness value should be higher, so it should be brighter in between the roofing tiles. So in fact, of making it better, we actually made it worse. which is also something which is also cool. Firefly, you did well. So what happened here? What did we do wrong? Let's see if our assumptions were right. So we are changing. These are good. 0, 1 to 7, 1 to 7. That's a value we've checked for most of the textures already. So that's cool. So maybe this also means that the nails have a wrong value applied to them. Okay, I see. I didn't save the background like 198. I made a typo. Or I updated the wrong color. Maybe I didn't have the background selected. So our texture was wrong. That's cool. And now because we don't link to the PNG anymore, it will actually immediately update in this file. Yeah, you can definitely see a different color, a bluer shade to this. So as we make more textures, we will get used to these colors and what they mean. And we might have spotted this problem way earlier in the process. I didn't actually see that I made a typo, or I didn't apply the coloring correctly. So converting the texture, here we go. And let's fire it up. And now it should work. We're in debug mode first.
Let's go.
Yeah, here we go. A huge difference, and we're actually, as you can see, the color in between of the tiles is very much like the stones right next to it. It's not entirely the same as the cobblestone that we have. So cobblestone might be just a bit more rough. Let's look it up in our code generator if we have a different definition for cobble. Yeah, so cobble might be bricks or something in between. But that doesn't really matter because we are already at a much brighter shade of gray in between of the tiles. So let's render it using the actual shader and see what it looks like. And now I'm pretty sure that the specular highlight in between the tiles will be much more spread out. Yeah, so very bright tiles, and we can't almost see, you can't almost even see the in-between portions. So maybe that's like something that we are going to do for future textures, and maybe for the existing textures as well, is to make the base material, what is kind of like hidden behind everything, make it very rough so that it doesn't really draw your attention as much. But this is looking good. Compare this or contrast this to the way the roofing tiles looked last week or last stream, and compare it to what they look like at the start of the stream. So already we're making great progress here, and I think this is a very good look for the roofing tiles. Let's go up on the walkway and check out what they look like there. So instead of having this very specular reflection going on in the entire texture, it's now only on the tiles themselves. So looking good here on the rim as well. So only the tiles are actually having this specular reflection. And here, yeah, this is so much better. You can see that the tiles reflect, but not the material or the kind of like part of the texture that's below the tiles. Check it out. Previously you wouldn't really see that these were tiled because the background would also like completely light up. Now if you move over to the other roof, we're going to check that out because they those tiles are aligned differently. These ones are like horizontally stacked sort of, and these are like more vertically pillowed outwards. So check it out. A nice specular highlight on the tiles and not on the background anymore. It's actually looking really good. Like as far as I can tell, this is very solid. So let me know if you think that the previous version looked better. It's something that we can tweak interactively in the future. We're going to have to define a style for the background of textures as well. But so far this is looking good. There's one more texture that we have to do. I believe it's the bark texture. So the bark is something that I drew this week, but we can take a look at it. Let's make a quick redo of adding these new texture styles, or these new texture information mapping material maps to them. Sorry. It's called tree bark. So let's make a base folder, move over these files into the base. We copy, I'm in your base. We copy over the material as ambient occlusion. Hey, oh, there we go. Hey, oh, there we go. You might see that I updated the file names for these. They now have this, it might be hard to see, let me zoom in. They have this plus crop C modifier, or at least file name modifier to them. That means that tells the engine that we want two versions of this texture, one that is full size and one that is cropped as a column, crop C, cropped as a column. Because we have column blocks that use these and we have full blocks that use this exact texture. And this way we don't have to make two textures, we can just reuse one of them for everything. So we can do a trick with the tree bark as well. We can say, I'm not exactly sure if this makes sense, but we could say that the inside of a tree, let's take a look at the values that we use. So bark is 0.9, that's pretty rough. It doesn't get much rougher than that. But we could say, and maybe you've seen this effect in real life, and I'm not sure if it's realistic to say so, but the inside of a tree is usually a bit wetter. And wet kind of means that the roughness is decreased, so it gets smoother. It reflects a bit more environmental light. And it's also got a more of a highlight to it, because the inside of a tree, like the bark that's inside of a tree, like the wood, inside of the bark is a bit wetter and it's a bit more bright. So that's what I tried to convey in the texture and the albedo. These are grooves inside of the bark, so they are lighter in color. And as you can see, the normal map kind of defines the way that these are cut out of the bark, so that's already working pretty well. So that's cool, that's entirely cool, but we could also increase the shininess, so decrease the roughness of these cuts in the wood, so that we get a more like vibrant material definition. So let's see, we have bark, which is 0.9, and the wood that we use on planks is 0.75. So we could use these values and it would maybe look like super stunning. So let's do that. Let's run with that. Let's see if we can make that work. It would be a very nice kind of thing that we could use these maps for, instead of just doing like nothing. Like the more information that we add in these textures, the better the materials are going to look. So we're going to make our base texture here, base material properties. Let's work in very broad strokes. So the background, like the bark itself, is going to be non-mixed in the albedo. It's not going to change its metallicness and it's not going to change its roughness. And I did it the other way around. So lock this layer, select this layer. We can remove the comment over there. Let's see if we use a single color. Yeah, it's going to look good. So let's use RGB. No albedo mixing. And metallic and roughness are going to be the same. And then for the grooves, here we are going to use a trick. No albedo mixing, so 0 in there. And then the metallic property isn't going to change either, and we want to stick it to the low side. And we defined, or we said that the roughness goes from 0.9 to 0.75. So let's open up our material value calculator. That's going to be minus 0.15 again. So do we remember that's going to be 108? It's going to be great. 108, there we go. So just a subtle, let me remove the, or hide the rulers here. A subtle color difference here between the background and the actual cuts in the wood. And the cuts resemble, yeah, so the B channel is going to be lower, so it's going to look greener, more greenish. So the cuts are going to be a bit more wet. They have a bit more like juice flowing through the tree. It's going to be younger wood. I think is wood pushing outwards or whatever. It doesn't really matter. It's going to be it's going to look pretty cool, I think. So that's our base map, and now we have to make a material map that combines the base with the other properties. So let's move over our calculating tool, our numbers spreadsheet. Let's keep it in our doc so that we can easily open it up like this, material value calculator. Color wise, I want to move it over to this place. It's not exactly making sense because Pixplant is more of an image tool that we want to use like on this side of the spectrum. So maybe we move Pixplant over here or in between Illustrator and Photoshop. I like ordering my tools by function but also by color. So this is just a bit of a thing that I do. Don't worry about it. It doesn't look good next to Firefox. And this also, like, where do we put it? PS, PX. We use it a lot though, so maybe it's best in that range. It's looking good. I also like it over here because then it bridges the colors between OBS, but don't worry about it. We're going to put it here for now. And now that I've told you this, you're not going to be able to unsee it, so be wary when watching my live stream. Alright, we'll make a new texture and we're going to place the base bark texture, just like this, crop to the media box, and we scale it up because apparently it was not scaled correctly. Make sure it's centered, it is centered. Apply transparency, we're going to place the ambient occlusion channel in this, and luckily it's almost sized correctly. Center it again, like this. We have to check this for the other files to make sure that we don't have like a 1 pixel offset or something. And we save this as material. So that's the material map for the bark. I never expected that we were actually going to use a material map for this, but now that I told you, it makes a lot of sense to make the inside of the tree have a bit of a different shade to it compared to the outside of the tree. So there we go. We compile the texture map. We convert it for our engine using our spiffy new tool. And there we go. We run it.
Oh, no time to waste. Let's go.
Alright, so here we go. So you basically now should be able to see a difference, and I think you can already see it, the roughness, like the difference in shading between the inside of the bark and the outside of the bark. So just a little bit of attention to detail in these textures, even though we have very coarse, cartoony shapes. See the way that the light reflects on the inside of these cuts? Like this shadow portion over here. I can't zoom this camera, but don't worry about it. But you can create awesome materials, even if they're in the cartoon style, using this. So I think we're ready to move into the world and check out some wonders. We might also want to update the stones, by the way, because the stones are everywhere. Not talking about the rolling ones, but the real ones. Also, we can patch up this bit of grass here. Looks a bit better. There we go. Righto. So that's the tree bark. I think it makes sense to change the material definition based on like how deep we are inside of the wood. You could also make it a gradient, of course. So you could maybe, like for a more photorealistic texture style, you could actually make the inside even more wet or appear to be more wet. But for now, I think for our cartoon style, this is like a good amount of detail that we just added. Just very different shading properties compared to all of the parts on the outside. Good. Looking good. Let's make the stones, and then we have all of our textures done, and then I think we will take a look at some wonders, see what it looks like. And then basically our material mapping is done. I might do another live stream where we look into the pre-lit factor. I don't really want to go into that right now because we'd have to draw an entirely new lantern block texture. That's going to take up some time. And we have to devise an algorithm for the pre-lit factor itself, so how that will render. So what I want to do for this stream, like I said, I want to kind of like stream until lunch. So 50 minutes tops, but I think we can do it in half an hour. We're going to do the textures for the stones, like the small rocks that are lying on the ground. We're going to revise the things that we did, so take a look at some differences left and right. And then I think we're going to wrap it up for this live stream. We implemented material mapping, we did all of the mathematics, we assigned color channels, we found a good workflow for making these maps, and I think that's a very nice conclusion to today. So we have something like working from start to finish, and it's actually like looking good. So that's it's just a nice improvement to the overall rendering. So I'm going to check the alignment of all of these ambient occlusion maps just for a second. 480, 482, 40 to 40, because I want to make sure that they are correct. See, this one is incorrect. And I'm not sure if it makes a difference in the output, because it might get rounded down, but it's something that we do need to pay attention to apparently. So we're going to have to resave some files here. This is a cinder block material. I just obsessively, like if there are numbers involved, I make sure that everything is perfect. Again, this one, it's off by 6% of a pixel, so that's not much. But it would drive me mad knowing that all of my textures are misaligned. And again, I'm not sure if it makes any difference for the final output. I just want to make sure that it's mathematically as perfect as we can get. And now, if we open them back up, okay, so they're still a little bit misaligned, but now it's 2,000ths of a pixel. So apparently this value is just very hard to represent in floating point or something, and maybe we'll just have to live with it that it's not going to be perfect. So once we make the texture, we pay attention that it's 480, 480 and it's centered correctly, and afterwards we just accept that there's a few thousandths of a percent, or like 0.2% that it's going to be off by. It's the way it is, apparently. This I can't live with, this I can live with. So we do our best to size it, align it. This is the wooden planks variations, there we go. I just obsessively want to make sure that everything is correct. So here again, we are pretty close to perfect, but let's see if we can actually make it perfect. And these things, again, you might not want to worry about them. It's something that I do worry about, and it's something that I think makes for a better product once you actually start to pay this much attention to all of the details. Like the end product is just going to be so much better. Save this, close it up, there we go. Now onto the rocks. In the block decorations folder. So our regular textures are done for today. Publish a sprite sheet one more time. So apparently some pixels did change, or maybe it's just based on the creation date, I'm not sure, but we actually have this file in the perfect, pristine shape that we made it in. Okay, so here you can see the rocks. They don't have the effect that we just had. And for block decorations, this might be useful as well. There might be parts that we want to make rougher and some parts that we want to make less rough. So don't worry about it. We're just going to do this very quickly. So let's make some base folders for these as well. Base rocks. In fact, we only have a single variation over here. So we do get medium ambient occlusion files, but we can probably tie them together. So maybe we don't have to make separate folders here because we don't get too many files. Same holds for the cinder blocks. Cinder blocks are going to be multiple variations. Roofing tiles might not be. So we might just move these into the main folder. It's something that I have to decide in the future. Or we can do it just like this, just right now, right here. Artwork production, cartoon, let's see. Roofing tiles, do we have multiple variations of those? Roofing tiles. No, it's just a single file in the original style. So we don't have to have a base folder for the roofing tiles. So boop. Like this, and then we can remove the folder. This also looks pretty clean. It's only 8 entries there, and I think 3 bark is the same. But we do have a different sort of tree bark, yeah, birch. So that's an entirely different texture. So tree bark we can't condense. Cinder blocks is going to have a lot of different versions as well. So let's keep the base folder here. All right, open up the rocks, and I think we can keep the rocks flat like this. We're going to copy the albedo to a base version of this. And I think this is going to be very simple because we want these to be non-albedo mixed. We don't want to change the metallicness, we don't want to change the roughness. So this is basically all we're going to get for these. And since we are doing it like this, we might also want to go with just full alpha like this. I mean, why would we want more detail or more stuff in there than we have? We can just make these fully opaque like this. Now we do have to pay attention, there's two rocks in this single file. So one is 120 by 40 and the other one is 120 by 120, 240 by 120, and this one is 240 by 80. We do have to pay attention to the sizes or the dimensions of these. We're going to copy these as ambient occlusion maps, so maybe we will regret our decision. Rocks PBR medium AO, and this is going to be called rocks PBR small AO. There we go. We have displacement maps, we have ambient occlusion maps like this, that's cool. And now we're going to make the material files for these. And the AO file is actually determining the size of these. It's 720, so we do a bit of scaling on these because they span the diagonal of the block, so they need to be, they have a bit more resolution in them. So let's start with medium, 720 360. A new file, 720 360. And then we place the base. And the base is going to be very simple because it's just, we want page 1 or page 2? Page 2, apparently. And we scale it up, 720, 360, center it, it was already centered. And then we place the ambient occlusion map for the medium rock. Just like this. 720. Okay, so it's perfectly aligned now. We're not going to bother looking at that anymore once we're done because it might change. And then we call this one, what do we call this one? Rocks PBR medium material. And we put it inside of the rocks folder because it rocks, yeah, whatever. Image size should already be consistent and should be good, so we're going to save it in the rocks variations. It should ask to overwrite because it's actually changing now. And there you can see the update. So that's the medium rocks, and then the small rocks are going to be 720 by 240. Okay. New file, 720 by 240. Okay. Place our base texture, which is this one. Place it. Page 1 is actually correct here. 720 by 240. Just like this. And then we add transparency to it, which is the ambient occlusion. 720 to 40, center it, and we're going to assume that this is going to save correctly. And we save it as rocks PBR small material and in the correct folder. I've used Illustrator enough on macOS to know that it sometimes wants to save in that previously selected folder. We override the file, which is good. There we go. Publish this sprite sheet. And then we convert the block decorations PNG. And we use 8 bits per channel. And the mat value isn't being used anymore. So hopefully this will work. We don't have to rerun the code generation, I believe, because the names and the layout of the texture itself hasn't changed. So this shouldn't return or update any files. And it doesn't, that's good. Let's head back into the game and see what the rocks look like.
Oh,
They
no
should
time
be
to waste,
absolutely
let's go.
good, like stunning, like they looked before. They're good, the lighting is correct, I believe. So let's open up the time lapse and see if the ambient occlusion and all of the normal stuff still works. Yeah, so the sun is to the right now. Sun is to the back right now. Okay, that's good. Sun goes down to the left of us. There we go. You can see the bottom left face is now being lit. There we go. Sun is rising on the left. And now it's actually to the front left, so it's actually in the shadow. We see the ambient occlusion. It's looking good. All of our materials have been updated to include material maps now, so that's good. It's all so nice. So that's that portion. We have our textures updated. I don't want to do any work on that anymore. I will look into this NS bitmap thing magic a little later, like after the live stream is done. Our material definitions we can close as well. We don't need those on the stream anymore. So what we did, this is just revisiting everything. So what we did is we added a material map. We actually include an albedo mixing component now. We allow a texture, a material map, to override the metallicness of a certain pixel in the world, the roughness of a certain pixel, and instead of like the and we also have the ambient occlusion. We moved it from like all of the channels to only the alpha channel, which is good. And in the next live stream, we're probably going to look at the inverse emission map. So that's something that we want to have for lights and so certain objects in the world that kind of radiate light out of themselves. And that's going to be something that affects the shading in the future. So for today, we focused on kind of like these channels. We already had ambient occlusion defined, but we also added albedo mix, metallic, and roughness in the material map. So we can take a look at that one more time after we're done watching some wonders. So we're going to take a look at what this looks like for the wonders, see what the change is with the wood. I'll get off my dragon here. So already you can see on the house of this account, there are some nails in this wood, and as you can see, they are very metallic-ish. And again, we might want to define a certain background material style for all of the textures, so that the background of all of the wood is, for instance, the same color and that it visually connects to other textures. That's something that I did with the base texture set in the current game, the current version, and that might also be something worth investigating for this texture style. Because if you take a look at the ruin stone and the cinder blocks over here, this is actually the same texture sort of, as you can see, but with a different color. But as you can see, the background behind the stones changes depending on the material. So on the, like right below my feet here is a bit of a brownish colored stone, which is called ruin stone. And on the right side of it, and to the left of it, and to the bottom of it is cinder blocks, which is more of a concrete material, which is grayish. But as you can see, there's a big transition in the background between these stones. So what we can do with material mapping is to get the same material properties along a variety of materials for those pixels in the background, so that they visually connect a bit better, so that you don't see this obvious like brownish background and grayish background. It's something that we could do today, but I like I said, I want to kind of like stop the stream at lunchtime, which is coming up soon. So that might be something for a future live stream. So maybe a future live stream will be doing the background properties for these textures, seeing what that looks like, and then working on the pre-lit factor. Maybe I can already implement pre-lit as a shading property, and then we can make a new texture map for the lantern to simulate or show the changes. So talking about that background thing, oh, take a look at like the way the roofing tiles now reflect. This is absolutely amazing. This is looking pretty good. And as you can see, the light is almost right behind me, I believe. Yeah, it's almost right behind me. So roofing tiles to the right of me will reflect from the left, and roofing tiles to the left of me will reflect from the right, because the light is in that position. And as the light now moves to my left on the back, all of the reflections will move to the left side of these roofing tiles as well, which can take a minute, but we can take a look at the effect in real time. So you can already see the light gradually moving over to the left side of these tiles, so looking good. But again, we defined a background or a bit of a custom background property for these roofing tiles already. So maybe we just have to go with a sort of darkish gray shade everywhere. We can use albedo mix for that. And then make it very rough, so that it doesn't attract as much light. So maybe that's something that we can try for the future. Let me go back to the game one moment. Here we go. So that all of the materials kind of nicely blend into each other. It's something that we already do in the current graphical styles for the game, and it might be like very applicable to this style as well, so that everything really stands out from the background. Something to consider. I might do some experiments with that this week already. Alright, so let's open up a wonder. Let's go to the first wonder, the striped road. Okay, here we go. Oh, check out the infinite dynamic lights over here. Check it out. Looking so good. These lanterns just reflecting on all of these tiles, I believe they are. Do we have any wood here? Yes, sir. In this building we have wood. So let's go in. Here we go. Lots of nails everywhere. Like on a smaller screen, on a smaller size, you don't see the nails that well, or they aren't as distracting. They're slightly... It's something that takes a bit of getting used to, so maybe we do have to tweak the coloring, the shading on these. Other than that, they're looking nice. They're looking good. Take a look at the way the nails reflect compared to the wood here. The nails are very shiny. They really reflect this red light really nicely. Maybe we can head up this ladder, see if we get some other effects. So there are no major lights near these nails, and as you can see, the nails are done darker than the wood. So it is actually a bit of a very photorealistic shading effect. Also check out these roofing tiles, looking nice. And here the nails just kind of blend into the background. They're not really that apparent. If you take a close look at the ground, you will see them, of course. But it's not like they are very distracting, so that's what we want to shoot for. There's some roofing tiles over there on that building with the blue and black. Looking good. There's some roofing tiles over there as well. So they are looking good with the new updated texture. Oh, there's a tiled roof on this building as well. Overall looking pretty nice. I didn't even notice the nails on this wood here, so that's a good sign. The nails are definitely more noticeable in these dark wooden planks. And now we are inside with the lantern, and now you can actually see some of the nails reflecting the light a bit better than the wood, depending on the angle that you look at it. Overall, solid. I give it a solid 9 out of 10, this effect. Up next, the Artisk Vorotka. So this is mostly using cinder blocks. Yeah, this is mostly using cinder blocks. The thing we can look for here is the directional shading from the lights, which is looking nice. As you can see, there's a lamp. This is actually a panel block that's somewhat transparent, I think. So you can definitely gauge where the light is coming from just by looking at this texture. So a very solid start. We also have some nice rocks over here, but we don't have any woods or columns or planks or roofing tiles here. So it's mostly a cinder blocks construction. Let's take a look at another wonder. Dreamicidia, built by Dadi. Okay, here we go. Finally. So this is a large wall made with dark wooden planks, and as you can see, lots of nails. There are lots of nails in here. It is realistic. It's exactly what we drew the texture to be. So no complaints on that front. It's entirely rendering the way we intended it to render now. But again, you can like aesthetically ask yourself, like, do we want all of those nails over there, or are they too distracting? They are very small details, and they actually do stand out a lot due to the way that this is lit. So it's something to consider. Maybe we make a separate texture for the dark wooden planks, and we just lower the intensity or like the apparent qualities of the nails. On the other hand, still, I believe it's... Yeah, we can still see them from here. I do believe it is realistic to add them. And it does give a very handmade or man-made vibe to the building, instead of having the regular tree bark, for instance. Oh, see these nice specular reflections in these blue roofing tiles? So you see the red light reflecting in the roofing tiles? even in the shadow, because of course the lamp still shines in the shadow. That's what I'm talking about. That's good. And this also shows you why it's a good thing to remove the roughness, or like make the roughness bigger in the background of the roofing tiles.
Hey, sweet haul.
I think there's some kind of like a bar building in this wonder. We're going to have to judge. Yeah, let's go on the right side. Conveyor belt over here. In this entire corridor made out of stone. And let's head over this way. Yeah, there's a huge bar, or saloon it's called. S-A-L-U-U-N-O-O-N, saloon. And it uses a lot of wood, so let's go inside of the saloon. Here we go. The $10 saloon. Yo, what's up? There's a lot of nails over here. So we nailed it with the look. But again, it's something that we can evaluate for the future if we want the nails to stand out like this as much. It's also going to depend on what the other textures are going to look like. What kind of blocks are these? This is black marble, for instance. So it kind of depends on a hollow scroll, and these are dark wooden chairs with maybe a reed cushion or a reed backrest and seat on there. So it kind of depends on what the other textures are going to look like. So my first opinion right now is it's very distracting to have all of these nails in here. It's supposedly realistic, and I can fully stand behind that, but it's a bit distracting to have all of them just thrown at you just like this. So either we lower the intensity of the color a bit, so that they're a bit darker for dark wooden planks, or we have to find some other way to make them look just a bit more subtle. But we have material mapping. It's working in the engine, so now it's just a matter of getting it to look good. I definitely like the nails in the lighter wood; those look good. But in the dark wood, it's just a bit much, I believe. You can leave your coat here. I will, Dottie. Don't worry about it. Next up, the City of Runeterra by Lieutenant Joseph. Lots of wood, lots of roofing tiles here, so this is the perfect test case for what we did. And so far, no complaints. Absolutely no complaints, at least not from my side. These are all the bright wooden planks, so they look good. The nails aren't too visually apparent. You can see the effect sort of, especially when there's light falling onto them. But it's not too overpowering, it's not too distracting. And the roofing tiles looking good. Check out the reflection of that lantern. In all, looking pretty solid. We're climbing up on the roof because we can. Custom says me likey, sure. But what did you think of the dark wooden planks? I mean that the roofing tile texture is much improved. That's super apparent, so that it doesn't have this shiny background anymore. Let's see if we can find something with the dark wooden planks. Solomon's Castle. We have a lot of cinder blocks here, and there's some roofing tiles in the orange color here, so can take a look at what that looks like. There's also a wooden building over there. There's a windmill, so let's head over this way. Is this wood? Sort of. Again, so I don't really mind the nails in the light wood. That's entirely acceptable. But I'm not sure about the dark wooden planks. We have some buildings using dark wooden planks over here, I believe. Up on the roof. Oh, just check out this reflection. Woohoo! I like it. I'm just taking a quick look at like why the reflection doesn't seem as continuous as you'd expect it to be. Like it appears that this row, column or whatever of roofing tiles is reflecting less than this row. Even though the texture is almost similar. So maybe that's something that I have to investigate a bit more. Definitely feels that like some of these blocks are reflecting less light than the others. So that's something we need to investigate. Yeah, so the windmill uses a lot of dark wooden material. In a way it looks very realistic. I mean, it is dark wood with nails in there. Check it out. There's definitely no confusion about what kind of material it is. But again, the nails might be just a bit too much. Maybe you'd expect them to be a little bit more subtle in this darker material. For now, we can run with this. I mean, on this side, I kind of like it because it makes it stand out from the background. And there's copper in between, looks like, yeah, copper. So check out that metallic reflection style, looking absolutely amazing. We're going to have to add some texture to make it look really, really good. We go into the tunnel over here, and here I don't mind the nails either, so that's entirely to my liking here. Is this rock around? Yeah, this is rock around. And Gaston says it's too obvious though. As in, you think it's too distracting to have all of these nails in there. So in regular wood, it's a bit more subtle. Gaston, is that what you meant? It's too harsh. It's not subtle enough. Like here I like it. Here I don't mind them as much. But for bigger areas that are very brightly lit, let's go inside. It might be a bit too harsh. Okay, so that's some good feedback. It's a bit too harsh, that's what I was thinking. Maybe like we can always keep this in mind, like tweak the intensity of that. But maybe some other things are going to change, like the background that I was talking about, like making the background more anonymous and a different color, and then adding some more textures to other parts, and maybe then it will not be as distracting anymore. Because they are wooden planks and they are hammered to the background, sort of. Let's open another wonder. Counter with Vivilia. I think we have a lot of tree bark here, so we updated the tree bark to be more glossy on the inside, where there's cuts in there.
New treasure smell.
I mean, if you take a look at this, I mean, it's also the build that you make. It's also how you build things and mix the blocks. If you take a look at this, it's a very nice difference between the artificial wood, so the wooden planks, and the bark out in front. See, because you can see that the wooden planks are actually hammered to something, let's call it something, like the background, and the bark doesn't have these nails. So it's actually a very nice textural difference as well. So I'm not a big fan of scrapping it entirely just yet. I mean, once you take a look at this room, for instance, sure, you do see the nails, and they do stand out. But maybe it takes some getting used to, and then it's just absolutely what you want. So it actually conveys some material information, some additional material information. I mean, the combination of the bark and the wood and the dark planks, I kind of like it. Here too, it really gives you a sense of what's man-made and what's a natural material. And I like the shading on the bark. It's a very coarse texture, but the way that we now defined all of the properties, it just looks very good. There's also a tree, I think, made with entirely out of bark, or made entirely... Yeah, here we go. I think it's a pretty convincing wood bark. Especially now with the subtle difference of like the cuts in the wood. It might be just a wee bit darker or so. Not sure. We'd have to see what it looks like with other textures applied and so. But definitely this table feels pretty good with the nails in there. And here just a few nails, like wooden plank blocks sprinkled in. What is the other wood like? What kind of block is this? A wooden frame. Okay, so we have to make those textures to see. So that's the thing. So maybe it is not too much. Maybe it's just the way that the build was made. I mean, this looks pretty convincing as a market stall. Sort of, and we have this very bright reflection in the nail heads over there. It's something we can tweak in the future if we really don't like it. For now, it just adds a bit of visual interest. And here you have a building that has a different building style. So this is made out of a lot of wooden planks. So you get more nails. I mean, it's the material, right? This is what it would look like in real life too. So for now, I'm not hating it. I can see, like, they are sort of distracting, but maybe it just takes a bit of getting used to the shading on this. And once more textures are added, maybe it's just entirely cool. So here we have the guards, again standing guard. Nice reflections on all of these parts. The roofing tiles looking good. These roofing tiles are now in angular formation, so that's a new style. Check out the reflection on this table here. Woo! Whoop, whoop. Here again, a nice reflection on the table. So far, I'm enjoying this. Let's go to one more wonder. Bivoy, also built by Angelio, has a lot of wood, a lot of dark wood. And here we see like, okay, there's a lot of nails again. The floor uses a lot of wooden planks here. There's a lot of nails on the floor. Hey, it's just the way that it's built. So not hating it, it's just a very different style compared to what we used to have. And it takes a bit of getting used to, but maybe once other textures are added, it is not as bad. We can always keep this in mind. I mean, we're not going to unsee this all of a sudden, right? The tree made out of tree bark, which is looking good. It's not only on dark wood, but the nails, like see there are nails on the light wood as well. The nails have the same color everywhere, but because dark wood is darker and the nails are like a little bit lighter in color, you just see it better on the dark wood. But even the blue wood and the pink wood, that's why I'm trying to get to a wonder that has differently colored woods, so we can get a feel for what it looks like on differently colored woods. This is the Halloween Terror build. I'm not sure if we have many colored woods in here. There are some market stalls over to the left. So what we can now do is say like the nails are always this specific steel material, and that way they look shiny and cool. So it is physically correct, but it depends on the base material, like how well you will see them. There's a bit of tree bark used in this part, but I don't see a lot of wood just yet. I do love the reflection of the roofing tiles here. The tree bark is also looking spiffy. The vampire. The Vendidor. Hello, how are you doing, Vendidor? I'm going to beat you up, thief. Oh, well, I'm not a thief. Don't beat me up, please. Okay, we have a dark wooden building over to the right here. Potentially also one to the left. There you go. With this is tree bark with dark wooden planks in between. And here we have a hut with a dry tree bark. Okay, looking good. Take a look at the shading of all of these grooves and cuts in the tree bark. It's just so realistic. Like different colors of tree bark, different colors of wood. And here I like the nails. It just adds this bit of humanness, like humanity or like artificialness. Artificiality. Whatever. I think this looks good again. There's a lot of nails. I mean, just as with the boxes at that one build at Bivoy, it's a lot of boxes, son. This is a lot of nails, but yeah, we have them. We have them. That's just the way that they look for now. And here's a combination of tree bark and wooden planks, dark wooden planks again. And I don't mind it. I mean, if you use the wooden planks like this as details, this actually looks pretty realistic and pretty good. You can definitely see the delineation between the wooden planks and the bark. I think it looks absolutely stunning, even. Let's open up another wonder, just trying to find some colored wooden planks. Here we are at Eclixia again. We already took a look at the bridge, which was looking good. And let's see. I think there's one big mansion that uses a lot of wood. And there's also a windmill that uses a lot of wood. So let's take a look at this. But it uses panel blocks, so it's going to be a bit hard to see what that looks like. But I like these here. I like these connecting pieces, these girders over here, these blocks in between of the bark. Again, you can now finally see a good distinction between artificial and man-made materials. Also the dark bark next to the light bark is just a nice touch, and you can see that the wood inside has a different color as well. So in all, like, check out the way that this looks. This is like the other way around, having the wooden planks in between the dark bark. So it's also the way you build it, right? So if you use a lot of wooden planks, you get a lot of nails. And this is definitely a more refined building style. And here I find that the wooden planks and the nails actually add so much value. This adds so much to the entire image and like the quality of the rendering. Just being able to see these pieces of wood connected to each other. I think this looks really good. And there's not too much nails over here. But like I said, there's a building with a lot of wood over here, so let's take a look at that. We just take a look at what things look like. So maybe it's just a matter of like the more detail that you put in your build, the better it's going to look. I mean, this archway looks absolutely stunning with the way that the light now reflects on it and in the nails. Absolutely stunning. Not too many nails, not too much reflection going on. Here too, absolutely good. This is also looking good. Are these doors? Yes, these are doors. Riders on the storm. So I'm not bothered by the amount of nails that's over here or that is in this building. I'm not exactly sure how this building was laid out again. So I'm not hating this. And this is a wooden frame, so the wooden frame doesn't have nails in it if I'm not mistaken. See you later, Gaston. So in all, I'm pretty happy with this rendering. And of course, you do get a lot of nails. But we haven't defined all of the textures, we haven't drawn all of the textures just yet. So maybe things will look much better and like evenly balanced in the future. Because there's going to be more detail in other parts of the rendering as well. So for now, I'm pretty happy with these changes and I think it looks really good. Let's take a screenshot here, because it's just a lovely place to be and to look at. This is the city X Bronx, so maybe we have some colored wood over here, in this wonder. We have market stalls, we have bark, all bark, no bite. Or bark. Wooden planks, hey guard, how are you doing? A wooden house. Not minding the nails here at all. Here's dark wood with the light on the nails. Yeah, okay, so they're less subtle, but they are realistic, and that's what I like. I'm not hating it. I'm not hating it. Equatoria, this is mostly metals, if I'm not mistaken. Yeah, so take a look at this. It's a lot of metallic reflections here. Lots of metals all around. I don't think that this build uses any wood, or maybe not even roofing tiles. So, oh yeah, there's a bit of roofing tiles here as stairs. They do look good, but there's not a lot of wood here. It's more of a metallic society. Glass, glass, glass. Okay, don't worry about it. Oh, we're still in Equatoria. Let's wait for a moment. This is my final water, so I need to get some more, but I will stop the live stream in a few minutes. Also nice reflections of the lamps here. Psychedelia, okay. This one might use differently colored wood. Let's take a look. Here's a bridge. I'm not minding this so much. And there's wood over there. That's looking good. Maybe we go into the material museum over here. This is actually the perfect wonder to visit at the end of the live stream, so we can... I think Infamous, who built this place, has added all kinds of materials to the material library or museum over there. Again, the shading on this material, or this wood, right next to all of the lava, is pretty good. I like the nails. Doesn't bother me here too much. Let's head into the museum. Here we are. Welcome to the museum. Now we need to find the wooden department. Where is it? So there are some benches over here. Okay, here we have the roofing tiles. All colors, so they are looking nice and spiffy. Oh, here we have the wooden department. We're going to shop for some wood. Alright, I don't mind it in the regular wooden planks, as we already deduced. I think the blue planks looking good as well. Yeah, if you see it by itself on dark wood, it's realistic. I'm not bothered by it. Like, the color contrast is of course a bit higher compared to the other materials, but hey, they're the same nails, so I'm not hating it. I'm not hating it. And maybe that's the only 3 colors of wood that we have in this style. Let's see. Shop. Wood. Wooden planks, blue wooden planks, dark wooden planks. Yeah, I think we have doors in pink as well and green, so there are some more colors, but it's all good. Check out the shading of the bark. So this one has got the wrong texture. I think this should be the birch texture. Okay, this is elm. This is actually a bark texture, that's correct. And this is a bark texture. Just check out the backlighting on this as well. The shading on this is now absolutely insane. So some very nice looking barks here. I can dig it. And the ceiling here was always looking a bit weird because it uses tables. And I didn't apply the normal mapping and the material mapping to those surfaces just yet. But now that that is fixed, you can actually see that there's relief, there's like shading going on these stones, and those are looking good as well. And the roofing tiles here, again, now that we removed the specularity, like we increased the roughness of the background, they look way more like roofing tiles. And here you can see one of the problems that I described. The background of the material is still colored the way of the material. So this has got a bit of an orange background to it, and blue roofing tiles have got a blue background, and black roofing tiles have got a black background. So I kind of want to make it so that all of these materials have the same background color. So if you mix and match roofing tiles in between each other, check it out, this is very reddish, and of course this is very purplish. So I think we kind of want to move to a albedo mix for the background, so that all of these have the same background color, sort of. If we take a look at that in the standalone building mode, so that those were some wonders. I like the look of them. If we replace one of these tiles with, for instance, orange tiles, let's see if we can find them, orange tiles, like this. So there's a bit of a disconnect going on here, and I might have to go into the cinematic mode here. There's a disconnect going on in the background color between these two materials. Let's use the zoom feature. So on the left side you will see that the background is a little bit blue, and on the right side you will see that the background is a little bit orangish once the sun rises again. One moment here. There you go. So you see blue and yellow in the background, and that's not the best way to make them connect to each other. So maybe we want to go to a single specific background color for everything, so that all of the blocks nicely connect into each other. I think that would make a lot of sense. And not only a color, but also a definition for the background. So make it the same roughness everywhere. And maybe the base roughness should be 1.0. So the very roughest material that we have. So that even stones that are as rough as that visually connect into their background nicely. I think that's something we have to copy over from the existing texture style into this new style, because it's going to make things look more consistent. Like, part of me wants to do it right now and show you what that looks like, and part of me says okay, let's maybe reserve that for the future live stream. Maybe we can do a very quick hack on this, on the roofing tiles. We do a very quick hack just to illustrate what it looks like. So we're going to use albedo mix for the background. So we're going to set the background R channel to fully red. Save this texture. So this used to be 0, now it's fully red, so we mix to the albedo channel, which is this neutral gray color. So it's not super perfect, but it's at least something. The background of this texture, as you can see, has changed a lot. So let's save this as roofing tiles, blocks, roofing tiles, variations, overwrite the file, fire up the texture packer, publish it, just to show you what this looks like and why we want to maybe shoot for that. So I believe the roughness for all roofing tiles is already identical, so the background should now have the same exact color for all of them. Except it doesn't, because because of reasons, and this is why I maybe didn't want to do it right now, because now we are left wondering, why is it not working? Let's debug this. Let's take a look at the oh, wrong button. So here we go.
Oh, no
I
time to
wanted
waste, let's
to
go.
I didn't want to do this, but hey, we're doing this. So if we actually take a look at the local material map.r,
Oh, no time to waste, let's go.
we are not seeing it pop up here. So you would expect the background to be fully white. Instead we are seeing the nails pop out, which should be the metallic. So what's going on here? Let's take a look at the green channel.
Oh, no time to waste, let's go.
Okay, so apparently what we are doing wrong is we're not doing anything wrong. Did we convert this right? Yeah, we converted the block decorations again, so we had to convert the regular file. There we go. It's fixed now. Here we go. The background is now a single color.
Oh, no time to waste, let's go.
It's brighter because we actually use the albedo value, but as you can see, the color in between of the tiles is now a single consistent color. So if we update the albedo to match, so we want to shoot probably for a very dark color in there so that it can be consistent across all of the materials. But as you can see, this way you can remove that kind of like background coloring going on, and you can make the background for all of the textures a consistent single color. That's something that we can do in the future. So for now, I want to revert this change because it kind of makes it harder to draw these textures. But of course, we need to define this very soon anyway, because we want to make all of the new textures the right way as soon as possible. Because if we define this style, it's going to be used everywhere. So every single texture that we create has to take this into account. Like, what does the background look like? For now, it looked better with the old definition because the albedo was way too bright here. But the effect itself works,
Oh, no time
so
to
that's
waste,
the
let's
good
go.
news. And as you can see, you can set the background color to a single color. So here we are back again with the colored background, but at least the roofing tiles look like roofing tiles again, and they are not on some kind of like weird gray shape. So this is all good. Let's close up our terminals because we did all of our work there. We can even close Xcode. So what we did is we added material mapping in the fragment shader. This line for debugging can actually go now. We added material mapping to the fragment shader. We added material map information. So let's again quickly open this up. We added material map information to all of the existing textures that we have. So metallic nails on the wood, for instance, and a bit of like more shininess to the insides of tree bark. Everything looking good. It's all working as expected. We did have to do some math on some of these things, so we created a color calculator, a material value calculator as well. It works, so that's the good news. It works, it's entirely cool, so we fixed that problem as well. And we're in good shape, so going back to the plan, let's quit out of Xcode and let's go back to the plan. Where we started is defining a material map with albedo mix, metallic roughness and ambient occlusion properties. Emission is something we'll look at probably most likely on the next live stream. I want to add this, and it might be nice to do it interactively and designing a new lantern texture while we go, or like while we're at it. So this was the plan, to add the material map, and we did it. We actually have all four of these properties working. So we checked albedo mix, we checked metallic, we checked roughness, and the ambient occlusion was already working. And we made sure that it still works because it was a little bit weird with our texture converter. So we had to change our texture converter to actually properly convert the alpha channel of our texture. That's also working, so I have to commit that to the code base. And other than that, we're good. So material mapping is implemented. Took about like 3.5 hours, including drawing textures and including redoing the texture converter tool. So in fact it was a little bit easier, faster to do, quicker to do than like 3.5 hours. So I'm happy. This was what I wanted to do on the live stream. We didn't draw a new texture, unfortunately. That would take a bit too much time, but we can do it on the next one, which is most likely, or maybe I will be live streaming on Sunday morning, so that's 2 days from now. Same time, same place. Other than that, if you have any questions, feel free to leave them on the YouTube channel, on the YouTube comments. I'm actively monitoring those, so that's cool. If you want to like suggest features, or if you have some feedback on the way things look, maybe on the dark wood with the nails, like let me know what you think of that in a comment. I find it valuable to get interactive feedback on all of the things that I do, because the earlier that we define the style and make the style the best it can be, the better all of the future textures are also going to be, and the better the game will look in the future. So thanks in advance for all of your input. Let's clear out a trash bin. And this was the stream for today. So material mapping is working. I'm going to clean up and commit this code. And on Sunday, like in 2 days from now, hopefully we'll be taking a look at the emission maps and emission property for some materials. And we'll make something new and awesome for that. So thanks for watching, and thanks for all of the feedback that I got so far. And I hope to see you again on the next live stream. And yeah, that's it. See you later. Bye bye.